Okay, there we go. Oh man, I almost accidentally stopped the stream. I take 1 week off, 1 week, and I'm that rusty. I almost hit stop streaming. I would have been pissed. It's too late for that. All right, please hit the like button and let me know how the sound is in the live chat. Um, super chat and gift goals are now in the plus menu. Apparently, it's showing me. So feel free to super chat. I always appreciate it. It takes a while for me to collect from YouTube because they make you hit a certain threshold of $100 before you can withdraw, and it takes me a while to get there nowadays. But I appreciate every bit of help, and that starts with please hitting the like button, subscribe if you haven't, hit the bell notification. We do these once a week unless my daughter gets me sick again. Uh, I'm trying to still get over it a bit, but and I think we have a great stream lined up tonight. This is one I wanted to do last week, but I was ill, so we're doing it this week. But we're going to talk about Stephen Wolfram and his Wolfram Physics project. Stephen Wolfram, I think, is one of the more he has more moments of genius than most leading voices in the scientific community today. And we're going to talk about where I agree with him and where I don't agree with him. I was actually, blessed to meet Stephen Wolfram about, I think it was about a year ago. And he gave a talk at MIT at this conference that I attended, and I did get to ask him a question that I had been trying to ask him for a few years, that I had wanted to ask him for a few years. I hadn't been trying, but I had always wanted to ask him if I ever, had the chance. And I got to ask him a question, and he gave an answer that I didn't expect actually. So we're going to talk about that, and how the implications for his it has on the differences between his conception of the universe and what fundamentally exists versus sentient singularity theory, and as a model, and what I believe fundamentally to exist. But we have a lot of similarities. If you look at his uh, hypergraphs of the universe and his generative Rule 30 models and of cellular automata, they look very similar to my the animation of my cosmological verse. And it's funny, I had a model, I had a video of it playing at this conference on this table, and I just saw him like across the room, and he's just staring at it, and for a while, and then I went up and I was like, yeah, that's my work, and it had like a description of my work. I didn't like get into it too much, and he was just like, okay. I was expecting him to ask maybe a question about it because it looks so similar to some of the things that he does, but he didn't. It's weird how like sometimes when you are similar to somebody in certain ways, it's like it doesn't have the has the opposite of the effect that you would expect. It's like avoidance is, is kind of the vibe that I got. I might be reading too much into it, but it was interesting. But he was very nice, and I will say this: he gave everybody who had questions for him, including me. I had one question. A more time than any of us needed. I mean, he stayed for probably hours afterwards, after his lecture, talking to everybody, and that says a lot about somebody. And uh, nobody's perfect, but I think that's an admirable thing, and I appreciate it. So did everybody else there. So just wanted to share that. But so he gave a talk on Big Think, which I used to watch a lot of Big Think about 20 years ago, it seems like, maybe 15 years ago. And they can have some good content still sometimes. And they had Stephen Wolfram basically give a lecture where these questions are posed, and he gives his answers. And we're going to go through it and discuss what it means. So this is the talk that we are looking at.
Those atoms of that.
Hold on. Okay. Physics doesn't explain the universe. Computation does. Stephen Wolfram full interview, and it's on The Well and bigthink, and his is cross-posted by 3 different channels and his channel. I don't know The Well, but makes sense, the name of it, The Well. The well of wisdom, I'm guessing, knowledge. But the link to the full lecture is below, and I always encourage everybody who watches this to also watch that. But you watch this first. So, first clip, because it's late. Requesting flyby. I don't know what that means, but you got it. My daughter told me today when I was trying to put her to bed before this, which is a part of why this got started so late. She just goes to bed very late. She's learned that she can say anything to just like extend bedtime. She's hungry. She wants bread. She wants more water. She tells me now, I want something. Like, that doesn't tell me anything, baby. Like, I want something. I want something. Like, that's not enough information. But it is for what she's trying to use it for, which is just that she doesn't want to go to sleep. And but she got all 3 giant like roller luggages and wheeled them to the door, and they're still there before I got her upstairs. And she told me she's going to the airport to fly on an airplane. So she's very into flying. That's what brought that up. And then we had to read a book called Busy Airport, which is actually a pretty cool book. It's like got like all these mechanical things in it. It's like a little kid book. But here we go. First clip.
There was still at that time people like, I don't know, Descartes was saying, within 100 years, we'll just have understood everything. We will have managed to just decode how our universe works. That didn't happen. What seemed to happen was, as people discovered more kinds of phenomena, the theories got more complicated. And what happened going into the 20th century, I would say that an important sort of trend was the idea of formalization of things, which came to mathematics in the course of the 19th century, the idea that mathematics could be built up as an almost logical, structural kind of thing, rather than something which was kind of an almost empirical way of describing the world as we perceive it. That was something which, coming into the 20th century, I think influenced kind of thinking about physics. And the 3 big theories that have sort of dominated 20th century physics are general relativity, the theory of space-time and gravity, quantum mechanics, and statistical mechanics, where sort of the key insight is the second law of thermodynamics, the idea that there's a tendency for systems to kind of get more random in their behavior through time. Those are sort of the 3 big theories of 20th century physics. And they all rely on this kind of formalization that was a thing that had sort of emerged in the 19th century. Then the question is, okay, so we've got these general ideas about how things work. How specifically is our universe built? And is there some underlying structure that is underneath those theories? Well, there were ideas like
Okay, so if you follow this channel closely, you know that I'm pretty critical of when of a lot of different proposals for fundamental theories of existence, and from a linguistic standpoint. So when somebody says string theory, like that, strings of what? If all the universe is matter, made of matter. What is matter? That's my question. Or when people say idealism, it's like it's made fundamentally of ideas, which they would say it's consciousness, really. But again, I think an idealism is the wrong term, because it's named after something that comes from something more fundamental. So your name of your theory needs to be basically the most condensed version of your theory. I'm writing a paper. I've been working on it for a very long time, and there's many reasons why it's going very slowly. But be in the next month, maybe next week or the week after, we're gonna spend an episode this month. I'll say spend an episode going through the different sections of it. We're not going to get into everything that I've written so far because I'm just not ready to share all that. on sentientsingularitytheory.com, the basic abstract, um, more or less, is on the writings page on my website, which is linked below. So you can read the abstract of the paper at least. But the um, the the point is that sentient singularity theory is condensed. It is the essential claim of the theory, is that is contained within the title of it, um, the the name of the theory, which is that existence is fundamentally singular in nature and sentient, and that singularness by nature is sentience on a fundamental level. And so this is the foundational assumption of the structure and the nature. Structure meaning being singular, nature meaning nature being sentience. So its nature is that is sentient. Existence is fundamentally sentient by nature and fundamentally singular by structure. That's what sentient singularity theory is proposing. And so when somebody says that I have a computational theory of physics, and my what is being computed, what is computing, it's not fundamental enough. Even geometric unity, what is being geometrically united in if it is a truly fundamental theory, then it can't be, because the name is part of the theory. You can't say that the theory is what's in the paper that I post, but not the name is kind of just a placeholder. That's not how it works. This by the way, I'm not attacking any of these other theories, like emergence theory is another one. What is emerging? That's Clear Irwin's work. Assembly theory, like Lee Cronin and Sarah Walker. What is being assembled? These are not fundamental theories of existence. They might be true theories, accurate theories, at least in their basic, in their most important components. And they might be more fundamental than any of our currently accepted, theories within academia. But that doesn't make them truly fundamental, totally fundamental. It just means that they might be more fundamental than what currently is accepted by mainstream academia. So you have to kind of have a term that is self-contained. There is nothing else required. When you say string theory, string is a structure. It's not a thing in and of itself that is self-contained. It's a shape. It's like saying circle theory or square theory. Squares of what? Circles of what? Strings of what? Emergence theory. It's like, what is emerging? It can't. There's none of these terms, these names, are self-contained in their description. That's my point. So then again, they could be correct. They just might, but they would be placed into a context that is more fundamental than the context of just those theories. And anybody that says that, like, you're just saying, you're coming up with your own definition of like what matters here by claiming the name matters a lot because I'm using it as like a way of giving myself points or something. No, it actually is a requirement. A theory is fundamentally, as much as we can even conceive of the point of it, it is formalized for the sake of communicating it and to others, so that they don't have to discover it on their own from first principles, completely from scratch. Every single person. It's that somebody can read it and or hear it and they don't need to like go through everything on their own to come up with it. But the thing is when people talk about computation specifically, and I talk about this with Stephen Wolfram, this is kind of my biggest like issue at this point with the way that he speaks about physics. and again, we look at things through a linguistic lens on here quite a bit because it is the medium of our of the sense making that can be done between you and I and others. So any other medium in which sense making occurs is internal to you, is personal to you, maybe not internal alone. It could be logic in your mind, or it could be personal physical experience. But as far as you and I having trying to sense make about concepts beyond our immediate physical circumstances, it requires the context of that is language. So you have to work within that you have to understand the rules of that. And so when he's talking about computation as being a new way of looking at physics, I don't understand how that's a new way of looking at physics, because I think it might be a new way of how, compared to how many people think they think about physics or feel they think about physics, as just being these little particles of like sand or something, like there's of matter, but that what is matter? That isn't actually how physics. That's not really like when you understand physics, what physics even is. Even if you understand it as well as like the best anti-theistic, physicists do, that's not accurate. So, but the thing is that, and I've said on before on here, is computation just implies that it just means that that there's causality, like, which is same thing as physics. I throw something and it hits something and there's an impact of some kind. Our physical world is that which we experience that cannot be overridden mentally alone. Again, I've used the example, if I think about the door over there as being, it's white, if I think about it being red, I've changed the color of it in my mental picture, but I can't think it to be red in the space in which there's interaction, meaning like the space in which I'm not the only one that will perceive the door. My wife can perceive the door. My daughter can perceive the door. If you were here, you would perceive the door. And I couldn't just think it red through manifestation. If I could, then that's not a power that comes from you. that's probably the definition of a miracle, and God's doing something. But this is the definition of of the physical space of physics. The space in which physics is observed, is in the space in which change happens that comes from a source external to us and cannot be overridden by our just mental thoughts alone. So what that means is that there's just physics is the space of causality that is beyond your complete mental control, I guess you could say. And it's the space in which of where there's causality happening beyond you. Okay? And computation is just causality. It's just using the laws of logic that are intrinsic to logic and taking advantage of causality being a thing that exists, or I don't even know if it's calling it a thing is correct, but causality existing to make an impact towards a desired goal. That's it. And so I don't understand how computation is a different way of looking at physics, really. I just don't. Maybe it is compared to how some people think about physics, but that would be like an incorrect way of thinking about physics. But when you understand that the definition of what physics is kind of what we physically perceive, meaning like that which is beyond our complete mental control. I'm just thinking of that. What is that movie? Dinner for Schmucks, where he's like, I have brain control. He's like, or he's like, I have mind control. Zach Galifianakis is at a dinner, and they're where you bring like the biggest idiot that you can find, and idiocy is a moment, by the way, that we all experience. There's no such thing as an idiot. There's moments of idiocy, and we all have them. I tried to open a gate the other day by like pulling it, and you push it open, and I've opened the gate countless times, and that's a moment of idiocy that I had. But so genius is the same thing. Genius is a moment, not a person. And but he brings up, everybody picks a person and to bring to dinner, and they vote on like who's the, you know, biggest idiot, and they just get into a fight over like what is more powerful, mind control or brain control. It's very fun. It's a ridiculous movie, but it is funny. And but so when you were talking about physics, how versus computation, the context that's different is that computation takes place in, it leverages physics to create a cyberspace of in which we can in, use the laws of logic and causality to make an action occur, basically through our understanding of a certain pattern. That's what it is. It's basically, I know that there's a row of dominoes, and if I hit this domino, I know that it's going to knock over that domino. But then you just get more and more complicated, and then you get Turing's machine, and then eventually you get like your Apple computer, and so on and so on. So, but it's all fundamentally the same. They're not actually different. A calculator that from 1980s is just as I don't even want to say complicated. It runs on the same rules and is no different in how it works than the most powerful supercomputer that currently exists in the world. And the only difference is in how quickly it can manifest causality, the patterns of causality in a cyberspace environment. And so that's the only difference between a computed the context of computation versus the context of physics, in my mind, is like one of them is our physical space, the other one is cyberspace. And those aren't really that, the difference is where we are. It's not really like a difference in how either one of them work. And so I don't get why that's a new kind of science he wrote, which is the name of the book that he wrote that's very famous, A New Kind of Science. And but I will say that the way in which he looks at the world is causing people to get a bit closer linguistically to the truth, and that is helping unlock some new understandings, and he's definitely having that happen. So I'm not saying his work is just useless or something, but it's like when people say, I think about the world as a simulation. It's like what we're really saying is thinking about the world in the context of it potentially existing in our physical space is really, that we experience as physical, is really cyber in a different universe, in a preceding universe or something like that. But simulation is not a good term, because if you're real, it's real, and simulation is by definition like not real. It's like a very limited model of a system that exists in actually a much greater context to just try and make a prediction or something like that. So like you couldn't, if Sims characters in the game Sims were actually sentient, you wouldn't call it Sims. It would just be like, that's computer land, like where people actually exist, like sentient beings exist, but in from our perspective, it's in a cyberspace environment, but from their perspective, it would be in a physical space environment. So it's us that makes the difference. And the thing is that Stephen Wolfram knows this, and he says it a lot, and he says it in here, and we're going to get into it. But so I don't know how. I'm not saying that it's not computational. I'm just saying I don't understand how that changes anything. It's just saying there's causality. Yes, there's causality. So Doc Barati likes to talk about future causality. I don't know who that is, but I'm going to look it up. Multiverse. There, in sentient singularity theory, there's an infinitely repeating, not or replicating series of nested verses, I call them, or cosmological verses, and one within the next. Once we get to a certain point where a technological being is manifested that achieves wisdom in the world, and that we effectively become the cells of, just like your cells are you, make up your body, we will make up the body of this being. It's basic. I call, if you look at like a city, once I was flying on a plane and I was looking over LA, and I just saw like, I was flying it back into LA, and I saw all the buildings, and I saw like all the cars going on the highways and stuff. And I was like, it looks like a microchip. And then I was like, it looks like a macro chip. It's the macro chip. And so that's what it is. Technological civilization is the macro chip. And it all started with the development of the knife. First piece of technology, true technology, which it means like something that has to be created to create something else. The thing that once it's created can be used to create everything else. And it's not something that exists in nature. A sharp knife is not something you find. Even obsidian, like, you have to crack it. And if you leave it out in the elements, it's going to get dull, like, fairly quickly. And so you have to make a new one to have a sharp blade. A rock is a hammer, and it exists already. You can use it as a tool, but it already exists always. Same thing with like a stick. But the knife is the first tool that constantly has to be made anytime that you need a new one, or that you need one. You don't just find one. And it is the tool to make all other tools. You don't make up any other tools without a blade. There's nothing. You literally cannot. So, but it created the macro chip. That's why it's there, and we talk about it on here sometimes. So here he's getting into the consequences of computation.
Understanding of the world.
Okay, so what is computation? The way I see computation, it's the following of rules and seeing what happens. So
Exactly. That's exactly what I've been saying for years at this point. When I'm like, I don't understand why this is calling it computation is like a novel way of thinking about it. But I will say that thinking about the universe as like a computer simulation, or being digital, did allow me to understand why we have a speed of light, which is really a speed of causality. And it's like the RAM speed. It start to understand it, at least. It's the RAM speed of processing. The speed of your RAM speed on your computer is the speed of light for the cyberspace that can run on your computer. It's just the processing ability of changes. It's like the amount of changes that can be processed, relative to a given action or a given goal. And so That's all it is. It's that the speed of light is not the speed of light. It's the speed of causality. That's actually what it is. It's the fastest that anything can happen. It's not just it's not just how fast light goes. Light is perception. It's the fastest that you can perceive things happening because it is the fastest that things can happen. So it's not even about the speed of your perception. It's actually just about the speed of causality, or the capacity of causality. It's kind of a better way of putting it than even speed. When you're thinking about it more fundamentally, or you want to discuss it more fundamentally, it's like the capacity of causality in a, in a given circumstance relative to a goal, is the speed of light, which is it's the speed of time itself. That's why when they say time slows down when you go for you when you go faster. So as you get closer to the speed of light, time slows down for you. It's that there's a bunch of things that need to be processed, and that you are impacting as you are physically, I guess, getting closer to them, and that causes a lot of things to need to be calculated, quickly, because you're moving quickly. And so that's what happens, is it slows everything down. So when you have a ton of things running on your computer gets really slow. That's exactly what happens when you're going really, really fast. Like you're going, 80% the speed of light, and time slows down for you. It's because that's what happens to your computer. So, I, thinking about this made me realize I had an epiphany. I was like, it's not the speed of light, isn't the speed of light. It's the speed of time itself. And I wrote it down in my notebook that I used to use before I used Excel, when I first started having all these epiphanies. I used the notebook just for planning, as a planner. And then I just was started writing all these epiphanies. And I remember I wrote down the speed of light is actually the speed of time itself. And I had things in there about dark matter, and dark energy, and why dark matter is probably the graviton probably doesn't exist, and what gravity is, and it's coming from the movement of the universe as a whole, and all these things that probably made me sound super schizophrenic. And if you didn't know me better. And I once left the notebook at the grocery store checkout, and I had my phone number in the front of the notebook, and it said, if lost, please call. And they called me, and they were like, "Oh, we found a notebook." It was with my girlfriend, who's now my wife, and I was like, "They just found my notebook. I left it at that's also my planner, at the grocery store when I was checking out." And we just both busted up laughing, because they looked through it, and they were like, "This guy is nuts." But yeah, funny. But yeah, this is what he just said. I don't even want to play the rest of the clip, because that is exactly what I've been saying. Computation is the following of rules, or is the consequences of causality in the context of certain rules, which is just causality again. But the computation, the term, if we look up the etymology, computation etymology, it implies causality in the context of a cyberspace environment, a digital environment. The word computation comes from the Latin word computatio, meaning an reckoning or sum total. It builds on the verb computare, to count, to sum up, to reckon together, combining the prefix together with to reckon. And exactly, though, I said a few minutes ago, your calculator from the 80s is the same exact thing as your cell phone today. And as far as just what's happening internally, not like the fact there's a really good, nice camera and you can call people on the other side of the world or whatever. But it's so much more than that. It's funny that we even call it a cell phone still. It's a digital multi-tool is what it is. But it is, what's happening internally is just the same thing that happens on the calculator from the 80s. It's just got a faster speed of light, basically, inside of its cyberspace, because it's got more computational power, capacity is a better word for it, computational capacity. So why the universe exists, this next clip. Dark matter and energy are the missing mass in mass defect. I know that. It's not. So it is. You're not wrong, but I have an experiment regarding mass defect. That's part of sentient singularity theory. Actually, it's about like I have a prediction about mass defect, and I don't know how to measure it yet, what I want to test, but we won't get into it tonight. But basically, that's when you add up the mass of individual like protons and neutrons, and if you added up the mass of them, then it would actually be slightly more than if you weighed the atom as a whole, in actuality. And so, but dark energy is that or dark matter is that to hold the universe together, basically there's more it would require more mass than to cause enough gravity, basically, then we can calculate to, basically it's an approximation because you can't weigh the universe from within the universe. But if we look at making an estimate of how much matter is in the universe, it seems like you need more gravity than would be generated by the amount of matter that's in the universe. So I just think that what this really is it is movement. Gravity is movement. It's fundamental movement. And so if you think about and you added up all the force that each of my cells in my arm or in my body is constantly, if you measure the movement of each of my cells in my body and you basically sum them all to get like a total force generated by all the cells in Tyler's body at a given moment while I'm, let's just say running, you'd probably be less than, it'd probably be like, I'm still working out how to say this part of it, because this is the context of my experiment, but there's added movement coming from me moving, not just my cells, is my point. What's so hard about this is that we don't think of gravity the way that the way that I think of gravity most of the time. The definition of how gravity is defined. People say it's the warping of space-time, and it's movement. First you have to answer what's the question of what is space and time, and what's causing the movement of space and time. That's what gravity does. It warps space and time. So what you're doing is something's causing the movement of space and time. And in order to understand what that is, you have to actually have a proposal for what space and time is, which we don't currently have. And Stephen Wolfram does propose it. And this is actually my difference with him, and we're going to get into it. I'll play a clip. And this is... The issue is that you can't actually accurately describe what's happening using the terminology that currently exists if the terminology that currently exists has been is contextualized in a false context. So, and that's exactly what's happening. And this has so many implications for even on computational irreducibility, which we're also going to talk about. But you have to start from scratch sometimes and build up, and then see if you can get what you observe. You can't work backwards, and you have to work forwards in order to sense make. And so that's the kind of the whole issue of why you can't unify quantum mechanics and general relativity, because that's working backwards. You're basically like trying to come up with a more fundamental context than both of those in the context of them, which isn't how this works. You have to propose a more fundamental explanation for something more fundamental, or more fundamental context, and then see if intrinsically down the road it leads to the manifestation of the patterns we see in quantum mechanics and general relativity. That's what you do. You have to, in my theories of everything, the how-to guide video that I put that I entered into Curt Jaimungal's Pace 1 contest that basically won second place. It was one of the second place winners. There's basically, you could say there was 2 second place winners and 5 first place winners. And so I was one of the second place winners. You have to start from scratch and throw everything out, and then just like think about things from first principles from the very beginning, and then build from there and see where you get to. And hopefully you get to the observations that we currently have in the model, and the patterns that we have in the models that we have of what we can observe. And you can't work from general relativity or quantum mechanics to a more fundamental context. So that's why you can't unify them the way that people are trying, because they have no ability to conceptualize of a more fundamental context because they're anti-theists. But Stephen Wolfram is a little bit different. He's kind of an anomaly. He can conceptualize of more fundamental context, which is just that there is a space in which there are logical rules that are intrinsic and inevitable, and that there are observers making taking actions within the context of these rules, and he calls this Ruliology. And sentient singularity theory goes a bit before that even, and has an explanation for why those rules exist. It doesn't just take it at the idea that like there is a rule. Or basically it seeks the first rule and the context of the first rule. And so you have to have the correct context to get the first rule. And you do this by starting by asking, what is the first question? And that's literally where you start when you want to build a world model completely from first principles. Is you literally ask, okay, like what would be the first question that you would ask about everything? And it's, what is the first question? It's a question that actually, oddly enough, answers itself with itself, and that is amazing. Actually, the answer to what is the first question is, what is the first question? That means it's an entirely self-contained, like causal loop of information. That implies that you actually did get the first question correct, because it doesn't require any other context in which it exists other than the questioner. And what's interesting is when you ask yourself, what is the second question? You get the answer is that, which is kind of the second question, oddly enough. But you actually get like the third question, which is like you get only by seeking the second question. It's very odd. But this is like logic building, literally. And the answer is, what is the truest thing that I know? And the answer is, for everyone, is I am. And so that is you get the context of like understanding and information itself, which is in the context of an observer, and you get the singular self-contained causal loop at the foundation of it all, which is entirely self-referential bit of information. So it's like if a loop of information is chasing itself, it's looking at itself in the mirror, basically. It is, I don't know how else self-awareness could exist other than if you were like, what is the first question? And the answer was, what is the first question? What that implies is it's an entirely self-referential loop of information. How is that not basically imply that fundamentally existence must be sentient? I'm not saying that question is sentient. I'm saying that question is a model of the complete self-referential nature, not just self-referential, completely self-referential nature of fundamental information. And information informs someone. It's not information outside the context of being interpreted by someone. Yeah, I mean, so you get stuck in this inevitable kind of space of like sentient singularity. But I hope that makes some sense. I was kind of rambling a bit, but this is what I mean is like, it's hard to talk about these things and explain my work in the context of their work without going through how I started my work, which is actually by asking, what is the first question? Not being like, how do I figure out, how to unify quantum mechanics and general relativity? I wasn't trying to do that. I was like, how does mind work? How does understanding work? What is mind? What is the process / structure that is mind? That was my question. And it's very obvious why I got where I got to. And but the thing is that Stephen Wolfram I think he has this like disconnect where he's got this, he's correct on so many things, but when you dig down into the fundamentals of like what he believes kind of to be existence fundamentally, he's wrong. And I know this because I asked him. I went up to him and let me play this next clip because that's the context of like my question to him. But is this when he's talking about atoms of space? And I asked him, do you think atoms of space could be this? Because he said there's these atoms of space in my model, and he doesn't have an explanation for where they come from or what they are necessarily, but he believes that they exist and that all we can tell about them is how they relate to each other. And it's like, you're not wrong necessarily, depending on how you define an atom of space, but also that you're not explaining why these atoms of space exist, what they are. And so it's not enough. There's like it's missing the fundamental context, which is the point of a theory of everything.
Start back in antiquity, people arguing, is the universe discrete or continuous? We learn by the end of the 19th century that matter is discrete. Kind of the realization that we've had in recent times, that's sort of the foundation of the things I've done, is that we can think of space as also discrete. And so we think, what's in the universe? What's the universe made of? Well, we think of it as a bunch of discrete atoms of space. They're not atoms in the sense of chemical atoms. They're atoms in the sense of being indivisible units. There are atoms of space, and the only thing one can say about the atoms of space are how they are related to each other. And we can represent that by a network where we say this atom of space is kind of connected, related to these other atoms of space. So we represent the whole universe just as a graph, a network. And we imagine that the universe and space and everything in it is just features of that network. What there ultimately is just this network that represents space and everything in it. Well, another question is, well, what does this network do? That might...
No, actually. Yes, that is not wrong in its kind of conceptual model of what space is and time. But even in sentient singularity theory, but saying what fundamentally exists are these atoms of space that we can't know anything about other than how they're connected to other atoms of space. That doesn't make any sense. And what is the cause of these atoms of space? Why do they exist? What are they really? Again, if you're saying things like there are particles that fundamentally exist. Particles of what? Of matter. Okay, what is matter? And but it's like saying strings. Strings of what? Strings of matter. What is matter? Again, you're just running into the same problem. You're saying a shape. You're like, there are these nodes of connected atoms, which just means like a discrete, individualized, or like, I guess, conceptually discretized structure. And when he said earlier, we learned eventually that matter is discrete. And I will say, I don't even think that is a good way of talking about matter, because outside of a kind of purely engineering context where you're just like, trying to build certain structures that would exist in the space of in the context of relativity. And so, but to say it's discrete, it's like, why are we seeing it as discrete? If you actually understand that mind requires a point of focus inevitably, like that would cause a discretized perspective because you can only focus on one thing. Like I've said on here before, one of my favorite lines in any song is when Kanye West is like, I like titties because they show me that I can think of I can focus on two things at once, something like that. And not to be vulgar, but it's just hilarious. But there's also like deep implications about it, because like you think about it and it's like you're not focusing on two things at once. You've combined two things into one thing. It's like saying I like cars because they prove that I can focus on two, or like I like bicycles because they show me that I can focus on two things at once because it has two wheels. It's like, no, your mind has made it one thing: a bicycle, a chest instead of a boob, and two different boobs at once. You're not focusing on two different boobs at once. You're focusing on chest. So this scales up and it scales down, and it has it really inevitable, I don't even want to say deep, but I guess you could say deep and inevitable implications about observation and perception that have profound implications about matter, even elementary particles like electrons. And so you could say matter is discrete. Because why? Because you can observe an electron, but an electron also it's the observation of the movement of information, which basically is a wave. And you observe it right there in that moment, in that specific spot that you're looking at, and it looks like it's a little particle. It's like looking at a wave through a very, very long toilet paper tube. It's just going to look like there's this circle of water, a single circle of water. But really, it's the movement of information on a in kind of a fluidized wave context that's beyond you, really. That's like way that you can't look at, because a wave is the movement of the ocean, really. It's like, and you can't see the ocean because it's just it extends beyond the limits of your perception. It extends beyond the horizon. So if you're really like thinking about a wave, like it's not even just a wave, a single wave. It's the ocean is doing this kind of. It's all moving. And so it wouldn't be the case if like it wouldn't be the case that waves were caused by at least some tides were caused by like the moon, if it wasn't the movement of the entire ocean. So really, there's a giant wave that you observe as a tide because it's just the movement of a single structure that is just on a scale that extends beyond the limits of your perception. So like this is the context of what causes us to perceive individual elementary particles is like at least electrons. There aren't a bunch of electrons really in the same way that there's a set number of people in a room. An electron is the maximum amount of electrons is the maximum amount of instances that can be observed of a wave in motion from a given point in space-time that of making the observation. That's it. And it's like space is discretized because the constraint because of the definition of focus and it being a constraint of mind, of logic within the context of mind itself. And that's why we observe discretized space. Time is something that we feel in. Time is just the time that when we say time, the time is passing. With the experienced time, all that means is there's causality happening beyond you. Again, just the same way that we talked about with physical space, or physics, that which is physical, which again, there's not really like that much of a, like if you think about physical space and you're like, you can really get into, people will go around and around if they start thinking about, is matter really like, is matter space, and is space or space and matter two different things? And already people do this with time and space, but it's like matter and space are not really that different either. They're just two different perspectives of like the causal network that we're in, of the causality within the network, of the network around us that we're within, is basically it. And so while Stephen Wolfram's right, space-time and matter are what is generated by the causal interwoven causal chains that make up this network of causality or computation, you could say, that we are within. That doesn't explain what, I think it does actually explain like what the context of these atoms of space are, which is, again, space and time, not different, just two different perspectives of causality happening, that is, happening, coming from beyond you, or that is extending beyond you, it's actually like space, time, and matter. It's like this triadic structure. It's not really just space time. And but this is the whole thing with unifying space, general relativity with quantum mechanics, is how do we unify matter with space and time. And so, but the reality is that they are one thing. Like they are kind of already unified. You just need to know the correct context in which you understand. Like from this perspective, if we're thinking like observing this, or and we have this kind of goal in our understanding, we're going to think about things, causality in the context of time. It's like that's happening over there, that's happening over there, that's happening over there, and I'm right here. And you know, we are going to perceive that as eventually the day going by and things happening around us and the sun, the earth, you know, going around the sun, and we're going to call it a day. But or the yeah, the earth going around the sun, we're going to call that a year, sorry. And the moon going around, no, the earth spinning around itself, basically, and are in the context of our perception of the sun. That is, we're going to call a day. So that was pretty bad. The earth going around the sun, we're going to call it a day. When I first had my bar mitzvah when I was 13, I went up to my rabbi invited me in before my bar mitzvah, and he's like, tell me what you believe about God. And I was like, I don't believe in God. And I was an anti-theist. I called myself an atheist, but really I was an anti-theist. I disbelieved that that existence was a sentient being that we're within. That's what it means to be. When people say they're an atheist, that's usually what they mean. But really that means you're an anti-theist. Theism is the belief that you are inside of a being and that existence fundamentally is someone by nature. That is kind of initial and eternal and all-encompassing. But there's no other type of theism. That's theism. But it's intrinsically monotheistic. There is no such thing as polytheism by definition. You've misdefined the term God in order to even use the term polytheism, or you're using it differently than I use it. But I said to him, I was like, I don't believe in God. And he's like, why not? And I was like, because we have fossils that are like thousands of years old and millions of years old, you know, not even just hundreds of thousands. I think you can fossilize some bones in hundreds of thousands of years. I don't know how long I'm sure it depends on conditions, but I don't know what the fastest is that you can fossilize bone. I bet you can put in like an artificial circumstance where you could fossilize bone very fast, actually. Like probably in minutes, if you think about what actually the process of fossilization is. It's just like the casting of, in some ways, of rock inside of a mold that was part of a living being at some point. But it's like when these people, who I follow on YouTube, they 3D print like, you know, a part that they want to actually be metal. And so if you don't have a metal 3D printer, they 3D print it out of plastic, then they dip it in ceramic, they let it harden, and then they, you know, dump in molten copper or something like that, and it burns away the plastic and replaces it with copper. And that's basically what happens in the process of fossilization. But this is like not even the preservation of bones. It's the casting of their shape. It's really what it is. It's the preservation of a shape that existed a long time ago, not of the actual thing that existed. But I said this to him, and I was like, we have fossils that are millions of years old, and you know, that the Bible says God created the world in 7 days. And he was like, well, what if one day for God is different than one day for us? And I was like, that's a cop-out. And we never talked about it beyond that. But the thing is in the Bible, it actually says God created the earth in 7 yom, or in 6 yom, not 7, but in 6 yom. On the 7th yom, he rested, which can mean day, but it really means period. So it can mean like a period of time or a period of events that could be apply to one day, but it could also not. And in the way that we think of a day as like, you know, going, the Earth doing a complete rotation, relative to the sun. And so, it's not even 24 hours. Like, we have basically two 12-hour periods in the United States, and they have 24, number scale in the rest of the world, or timeline on the rest of the world. I never understood why we have that in the US. It's way crazier to me than like even the imperial system. I understand why 12 is a good number. And I understand why 10 is a good number for the metric system. I don't understand why we do, like, 12 to 12 and then or two 12-hour periods with repeating numbers and then they just do 24. I think that the 24 thing makes way more sense. I have no idea where that came from, that we use, but I remember people would just call it military time, but then when I went and stayed with friends in France for a summer when I was in high school, they just were like, it's like, what time is it? It's 23, something. It's not like 12:02. It's like it's 23:02. Okay, that actually makes way more sense than 12:02. But regardless, okay. I don't even know if I answered what I originally wanted, but hopefully. Let me go to the chat and then I'll get back to it. Please hit the like button if you find this interesting. Sounds very interesting. Dark means unseen, transparent, invisible. Exactly. It's just a placeholder term. Dark matter is such a terrible term because it implies that your current conceptualization of matter, which is, by the way, not correct anyways for most people, is it implies that there is missing matter that we can't see. And so in sentient singularity theory, the graviton, if a graviton exists, is we're inside the graviton. We're the force carrier particle of gravity is the universe. It's that the force of gravity is the movement of the universe on a fundamental level. And so that means like on a holistic level. And so the force carrier particle of the context, the container of that force, that movement is the universe. And in the current theorized model of the standard model, which is wrong, is that there's these, or conceptualization of the standard model is that there is this elementary particle that we have not been able to perceive yet called the graviton that exists, and it has certain symmetry qualities, certain spin and charge that are basically symmetry qualities, relating it to the rest of the particles. And those, I think, actually are correct, but the conception that it is a little particle that we just haven't figured out how to see, and it exists in the universe, and that they exist in the universe, like there's a bunch of little gravitons around that we just don't have good enough cameras to notice, is nonsense. I think you're never going to find a graviton. You're in one. Like, it's the forest through the trees problem, and there is only one. I think that solves the issue with the graviton in the standard model, actually, and it produces like a very symmetrical. It explains, like, it gives context to why we observed the Higgs, and speaking of the Higgs, Eric Weinstein, I heard him once on a Discord call say that to a bunch of people, so it wasn't just me, so I'm not airing like a private conversation. He was like, he was talking to some girl who was a physicist who worked at CERN for a long time, and the two of them were just talking, I was listening, and she was basically scared, trying to nicely say that the physicists that she worked at CERN all have no idea what they're doing, and they all assume that the person next to them knows what they're doing, and none of them talk about the fact that they actually know what's going on, and that that physics is a mess, and that there's a serious lack of understanding of the field by people who are, in control of its most powerful tools. And um, and Eric stops her in the middle, and he's like, "Let's just be honest. The Higgs is bullshit." And she was like, "Thank you." And I was like, "That's amazing," because it could not understand the narrative about the Higgs. It did not seem to fit within sentient singularity theory, and all the rest of the standard model did, except the graviton. But it makes sense in sentient singularity theory if we're inside the graviton, and the Higgs does not make sense. And if you really dig into it, you're like, yeah, we observed something, but if you understand really what particles are and that they come from the constraint of mind when in the context of an observation, you can't not see a discrete observation if you're going to see any kind of observation. So it doesn't imply that there is this fundamental force carrier necessarily the way that it is proposed to be, which is, they'll say it's the force carrier, it's the of mass, but the graviton is the force carrier particle of gravity. But then if you start thinking about it, it's like mass and gravity are considered the same thing. So this is kind of redundant. Maybe we're talking about the same force being observed from two different perspectives, and that's actually probably what's happening. But I had never understood the Higgs, and I just kind of chopped it up to either mainstream physics is all wrong and the Higgs doesn't make any sense, and I don't understand why they think it does, or or I just don't get it, and I kind of just given up on figuring it out. And then I heard them say that, and I was like, dang, why can't anybody be freaking honest? Because I've been trying to understand the standard model for the last 3 years, and that's the only part that doesn't make sense. and hearing them say that was amazing. And then I heard Stephen Wolfram speaking to Brian Keating, who I used to work with Brian Keating when I worked at PragerU, and I always wanted to have him on here, but I haven't, and I haven't asked him, and maybe I will one day, but I haven't spoken to him in a while. But he's done some good interviews on there, and he had Wolfram on there once, and they were Wolfram said the Higgs is a kludge. We have to be honest, the Higgs is a kludge, and a kludge is that. What a kludge is it's this placeholder fix that isn't right, and that's exactly what dark matter and dark energy are. They are placeholder terms, but they imply certain certain concepts, because that's how language works. Is you can't use a term as a placeholder term and not have it also, inject certain definitions into it, and basically create a context in which you're going to be looking for what is supposed to occupy this placeholder term that's been generated by the placeholder term itself. It's not good. It kind of screws you, and because now you're looking for particle that doesn't exist, or matter that you can't perceive because you have a misunderstanding of matter, and you're looking around for the missing mass, and it's really just the universe that you're in is moving as a whole, and you can't see it, but it's applying force, extra force, that isn't coming from the individual actions of individual cells, or the individual movement of individual cells, or the movement of individual particles, I guess. Matter. Again, I'm trying to use the terminological context of our current discussion to describe what I think is actually happening. It doesn't work. So, yeah, it's tough. This is not easy. to talk about all the time. But Wolfram said this, and he was the third person that I heard say this, and he's only the third person that I've ever heard say this. I've never heard anybody else say it, but Wolfram, Eric Weinstein, and this female physicist who used to work at CERN when she was talking to Eric. And but if we look up the definition of kludge, an ill-assorted collection of parts assembled to fulfill a particular purpose. So basically, like, we don't actually have the real fix that we would want, but we can like hodgepodge something together that's not going to hold when you actually like dig down, when it actually is challenged, but it works for this limited context. Use ill-assorted parts to make something. Hugh had to kludge something together. Why is it not spoken of more? That like this, it's not even just not spoken of more. If you look up the standard model on the internet or in a book or whatever, in a textbook, it's going to include the Higgs as like part of the standard model, just like the rest of the particles there. And in some ways, it's still just an observation of a discrete observation, but of a point. But it's also different than the others. It's a kludge, and the other ones are not. Like an electron is not a kludge. Not really. In some ways it is, but it has engineering implications that I don't think the Higgs has. I don't think we have used the Higgs boson to like engineer anything, but let's see. No, we have not used the Higgs boson to do practical work or build tools. It exists for only a tiny fraction of a second before it decays. We study it at CERN to understand, there you go, to understand how the universe has mass, not as a material to use. It's a kludge. It doesn't exist the same way that the others exist. And even then, the others still exist only in the context of our observation, just like this, but it's not just the context of our observation. It's like the context of our trying to patch a hole without actually fixing it, the way that you should. Short life. It lives for a trillionth of a billionth of a second. This type of speech is completely gives a context that is not helpful at all. At all. Gosh. But if we look up standard model of particle physics, the standard model of particle physics is the main theory that explains how the universe works at the smallest, most basic level. Again, wrong language. It's not about size. It's not about really, really small things. That an electron is not a really, really small thing. It is a point of observation of a wave of motion, which is the universe moving as a whole. That discretized aspect of it, and the size that it is observed at, comes from the constraints of us as observers and the way our mind works, and the constraints of logic itself. And what it means to make an observation it requires looking at somewhere. It's about the perception of information in a specific context, which requires discretization, because context only arises in the space of relationships. Just like Wolfram said, the only thing we can tell about these atoms of space is how they're connected to each other. That's what he said. So I went up to him. I actually asked him two questions at MIT. I asked him, you said that the Higgs is a kludge. do you still believe that in the past, and do you still believe that, and like what do you mean by that? And I assumed what he meant by it, and he was like, oh, it's a total kludge, is what he told me. He's like, it's a total kludge. Like, it's obvious when you understand how it came about, and like when you look at it, it's and you understand it more, it's still a total kludge, is what he said. And I agree completely with that. Which is kind of amazing, because it means that like my initial, if you look at my website, Singularity.com, and you go to models. So some of the first like 8 are actually really specific models in sentient singularity theory. But after that, it becomes more just me exploring different symmetries and things like that, and how when certain quantities are generated. So when I first, many years ago, when I was trying to understand the symmetry structures in the standard model, I wrote this out, which, this is just me basically copying. But you don't see, you either have to put the graviton here or the Higgs boson in order to maintain this like kind of symmetry of two of binary trialities, basically binary trialic observations: electron muon tau, electron neutrino muon neutrino tau neutrino, up, down, strange, charm, truth, beauty for the quarks. And then for the bosons, it's these. Or you could say it's the graviton, but then you don't have the Higgs. And so you have to kind of pick one, which implies that this is one thing being observed from 2 different kind of like foundational perspectives. One is like a God's eye view, which is the graviton, which they don't believe that. They think, most people who are physicists today think it's a really small particle, which is not a God's eye view. It's an internal view. I think it's the universe itself. Or you're just trying to make the most fundamental observation that you can of like kind of static gravity, which we're calling mass, which is, it just doesn't really make sense. It kind of destroys the definition of mass and of gravity. But and so it's just not correct. But I had this other kind of model of, where is it? This. So here I was like exploring symmetries again here. And this is how, they kind of predict things in the standard model, is through the symmetry structures that what information would be required to create a symmetry within the context of what is currently observed. So yeah, we can't see a graviton. And subjective particle would be like the Higgs. But it's really one. It's like this thing is the graviton. And when you look at it most fundamentally in a weird context that doesn't really make sense, from inside, you're going to see like maybe an observation that we would then call the Higgs. And so, but this kind of fulfills like a symmetry. It's same thing with how they predict like the spin of a particle that they've never observed, or the charge of a particle that they've never observed. They have predictions about the spin and charge of the graviton. And so that's what I was just doing with this. And I'm modeling it in a 2-dimensional Excel structure, but you can do it with mathematics, and you can also do it with an arrangement. And so, but if you look there, like, it's like I'm having problems with the Higgs here and the graviton being like simultaneously existing, where you see here, I'm chosen to use the term graviton to describe this as subjective particle, which is like the observation of this of the whole from the inside, basically, which is the Higgs. I just didn't want to use the Higgs and the graviton because I think that doesn't make any sense. And so over here, when I put this other one together, I left out the graviton because I was like, you can't have the graviton and the Higgs. It doesn't make sense with symmetry. So again, you'll see all these other things, and I'm not standing behind my language that I was using. This is from like 7, 8 years ago. And a lot of this is just me exploring, but um, I'm exploring the symmetries in language in some of them, in the alphabet in some of them, uh, and in math, in numbers in some of them, and then also just in like, I guess you could say, cellular symmetry of the cells of Excel. So like here, I'm like looking at the angles that are created as we're basically circling a single point and generating in a generative way, and just like you can see this odd symmetry pattern of repeating, angles. It's fascinating. But yeah, I've had a problem with the Higgs since the first day I looked at the standard model. But if you look at this here, like there's no graviton. There's the Higgs boson in the center. Again, this is the graviton. This is this Higgs. It's the observation of this set of the like fundamental center point hole, whatever, from the inside. Like even in this model, it's like kind of lines up with what I'm saying, which is funny. But then if you like look at this version of the standard model, you get this issue where there's like, this like outside, kludge. That doesn't make any sense. Graviton. Let's see. Here's another model that includes the graviton. And you can see in the symmetry structures of this, like when you're looking at the spin and the charge, the graviton they give 2, the Higgs they give 0. But what if it was like you gave spin 1 to like the Higgs and 1 to the graviton? This is about this these observations, including spin and charge and mass. They all come from the constraints of mind and the context in which the observation is being made. Spin has to do with our minds, like how our mind processes information. Charge has to do with how our mind processes information. Mass comes from how our mind is processing information, also in the context of a network of multiplicity, of multiple observers, all simultaneously making observations. And those observations and then actions also have to like interconnect with each other. And so it creates this like capacity constraint that causes mass and speed. It's like, how can you increase mass by increasing the speed of something? It means that mass is not this like fundamentally existing thing. It has to do with context of motion, of action, within a network of observers and interacting beings. I like martial arts of all kinds. I've done them forever, and I talk about on here. I also shoot and like train with firearms, and I train with swords. I've done fencing and Japanese swordsmanship and saber fencing and foil fencing, and I've done all kinds of martial arts but the modern one is using a firearm. This is my rifle actually right here. I can't show it to you. It's right over there actually on the wall, but I can't show it to you on a live stream. They won't let me show firearms on a live stream, or else they'll stop it. Apparently I've never tested it. But that's my rifle. This rifle has a caliber of 5.56 or 223. It's a 22 caliber bullet. It's very, very small. An AR-15 has a very small bullet. It just goes very, very fast. It's the same size bullet as a 22 long rifle that you shoot in the Boy Scouts or whatever. But it just goes way, way faster. And so it inflicts way more force. That, again, is like an obvious example of why, you know, these things don't just exist in a, like, mass doesn't just exist in this objective way that most people think about it. It exists in a certain context of action and observation and interaction, actually, you could say, and interobservation. That's a term that I've never heard anybody use, and I've never used it before now, but I should remember that. Somebody write it in the comments below the video so I don't forget. Interobservation, and timestamp this. I'll turn it into a clip or something. But yeah, so you're just looking for symmetries in these various contexts. The graviton. Where's graviton? Right here. Not yet observed. Graviton hypothesized. Photon. So affected particles acts on bound states formed. So this is actually a pretty decent. But see, I don't see the Higgs here. Since, okay, it was developed a standard model describing 3 of the 4 known fundamental forces, excluding gravity in the universe, and classifying all. It was developed in the stages. Okay. With the current formulation being finalized in the mid-1970s upon experimental confirmation of the existence of quarks. Since then, proof of the top quark in 1995, the tau neutrino in 2000. I could have predicted, by the way, that you would find both of those through sentient singularity theory. And I can show you exactly why. And the Higgs boson have added further credence to the standard model. In addition, which is funny because this is like making it worse. In addition, the standard model has predicted with great accuracy the various properties of weak neutral currents and the W and Z bosons. Okay, where's the... For example, that does it not explain why there is more matter than antimatter. I mean, we don't even understand what matter is. So to think that we understand really what antimatter really is I think it's just insane. At least we don't understand what matter is in our current like physical theories, because you need a metaphysical theory to explain matter. You need to be the context of your physics theories. Like, matter is what matters. It is causality beyond you that you have to contend with. That is what matters to you always. It must matter. Matter must matter. Matter is what must matter to you. And so, like I said, if I think about punching you in the face, you are not going to feel it. And even if it makes me feel better, I wouldn't do that. But to you, but it's not going to impact you. It's literally, not or physically. But even if it impacts me internally, but if I actually physically punch you in the face, you can't think your way out of it. You can't be like, I just don't believe it. And through manifestation, I have made your fist disappear, and it didn't actually hit me anymore. No. you have to contend with it. That's what the definition of physical means. And so matter is what must matter, meaning like it is what you must contend with. It's the causality that you must contend with. Yeah, that's external to you. It means like you're not responsible for the causality, and you aren't the sole context of the causality either. Whereas like in your mind, if you're thinking about punching somebody in the face, you are the sole context of that causality. Which is just an information computation, whatever. Okay. It doesn't incorporate a full theory of gravitation as described by general relativity, or account for the universe's accelerating expansion, which is dark energy, possibly described by dark energy. Dark energy is a proposed form of energy that affects the universe on its largest scales. Its primary effect is to drive the accelerating expansion of the universe. It also slows the rate of structure formation, assuming that... Okay, so it's basically like macro decay, it seems. I think that dark energy is... it's funny because we call it dark energy, so we're looking for like a source of the energy, I guess. But you can't look for energy. You have to look for like the source of the energy, and we're kind of just looking for energy. Why would you look for the source of like the growth of a structure that you're from within? It just doesn't really make sense. And if you think about yourself as a cell inside of a body, that's growing, like you're the cell inside of a little kid, and you're, I don't know, a blood cell, and that little kid gets taller and taller and taller and grows. What is the world going to look like around you? Probably like it's going like this. And especially if you're like looking to see if that's what's happening, you're looking specifically to make, for evidence of spatial expansion of space itself, which is like, if you're a cell, that's the body that you're within, which is exactly what is happening in a way that in a body that's growing. And I think that that's exactly what dark energy is. That's my explanation for it. As more sentient is generated within the sentient being that is the universe, or then it's growing. We're inside of a being that is growing. And then dark matter is that the being that we're in is moving around, not just the cells inside the being are moving. The universe isn't this static thing where like everything inside it is moving, but it's not moving. No, it's moving, and the things inside it are moving. Really, the beings inside it are moving, and it is a being that is moving. And so like you can't you'd see the effects of that holistic motion of the universe from within it on the impact it has on causality, of everyone inside, but you wouldn't see the source. And that's exactly what we see with dark matter. And so I wrote that, by the way, I wrote all of that in like that notebook that I left in the grocery store that they found and read through. And it was like, dark matter is actually, the movement of the universe. And then I eventually started keeping these things in my notes because dark matter. Let's see when I wrote the last thing about dark matter. On the 11th, on 11/17/2017, or 11/10/2017, I wrote, wait, no, that's something else. I searched matter and something else came up. said on 10/11/2018, actually, literally almost exactly a year later, but it's like flipped. Instead of 11/10/17, the next entry is 10/11/18, which is weird. It's like a month and a day, a year, a month, and a day difference. 1 year, 1 month, and 1 day. I said, dark matter doesn't exist. God is just squeezing things together in order to create, which basically means like he's acting and we're inside of him. He's moving. And God is existence itself as a being that we're within. Then I wrote also again 8/1/2019. Dark matter is just the excess force, the universe consciousness. That's what I was calling it at the time, instead of like sentient universe. I was calling it the universe consciousness because, again, this is like way before my language was as formalized as and flushed out as it is now. And I don't have it figured out on everything, but sentient singularity I've got figured out. And I didn't at the time. It said dark matter is just excess force. The universe consciousness is purposely applying on the consciousnesses that are created within itself for the purpose of giving energy in order to power and the animation of and generation of more consciousnesses. So basically, like, just like you are eating, and drinking water and everything, and it's like sustaining yourself. You're taking actions for the sake of sustaining and caring for your cells. Like, this is, you're moving to achieve goals that you need to achieve in order to sustain yourself, basically. And that sustainment, or I guess not even sustainment, but growth of yourself, and that growth and actions of yourself as a whole also are responsible for sustaining everyone that makes you up, basically, that makes up the body that you are building. Which is, if you think about the context of you being the universe to your cells, or you being even almost God to your cells, and your cells are like us within God, which is a little different for its existence itself versus the universe, which it just depends on how you define the universe. I don't define it as all that exists. I define it as, again, I don't really like the term universe. I call it a verse. But yeah, it's like the second being that's created within sentient existence, which is sentient existence is God. In my model, I would say that the universe is the first being that is created by God within himself. So it's the second being to exist, and the first one to be created, and then everyone else is created within that, and that's the universe. And then it just hits a certain point where it just is replicating itself within itself, which is exactly what we see in life, in cellular life. The only difference is that a universe doesn't give birth to another universe outside of itself. It gives birth to another universe inside of itself, because it has a unique constraint that we don't really have. I mean, we do, where like you first give the generation of another being, in the replicative process of reproduction, is always actually internal. It's just eventually you can give birth and that being comes out, but the being existed before it's born. And I can tell you that for sure, because part of why I was late is because my wife is a month away from giving birth, between 1 and 2 months away from giving birth to our son. That boy is moving so much. I can see her stomach, like I can see like a hand, and he was moving more than he has, and we were like, is everything okay? Because I'm seeing like feet kicking out, and it is wild. It looks like the movie Alien, if you've seen it. It's pretty crazy. I had a video on here of my sun moving, but I don't know where it went. But here's a static picture from a while back. That was like, when did that? That was in April 14th. I took a screenshot. So it was like back in April that picture was taken. So yeah, we're gonna have some weird hours, and I'm gonna have to take a break a little bit from streaming for at least a couple weeks, or maybe at least a week, but maybe two, depending on how everything goes. Sometime in the next month, whenever he decides to come out. But he already exists, and so humans even replicate within other humans. They don't replicate outside of other humans. But if you are the universe and you have this constraint of oneness, there's nowhere else for being to be born into. There's no other space for the being to be born into where it could sit next to you. It's weird. It's a weird constraint, and it has to do with like the process of how a universe reproduces, and it has to do with like the internet basically becoming sentient and then recreating another universe inside its own cyberspace. But that means that like there's no second cyberspace, you know. You can't have that being jump out of that space and then be in this space. It's just nested, if that makes any sense. Yeah, that's like makes us different. Here's like a it's like, I don't know, I can't think of the right way like metaphor for it right now, but there's two different like aspects to evolution in sentient singularity theory, and one of them is replication, which is basically multiplication. And it's, if you look at this model, if you go to overview, this is a very old overview. The paper will be much better. This is a model of like evolution happening in the periodicity that's of fundamental structures which are sentient beings until you reach the end here. And its evolution didn't start with cells, like molecules, atoms also evolved. The first being assumed to be a sentient being inside of the universe in sentient singularity theory would probably be a proton and neutron, so a hadron. And then but atoms, then once you get to atoms, you get like this evolutionary process inside of stars where it's just different elements, but they used to call them different species of atoms. You know, a helium atom, the helium species evolved from the hydrogen species, and eventually, like, they all have a common ancestor. You know, gold and helium have a common ancestor of hydrogen. It's the same thing as like all cells have a common ancestor. Even all single cell, you know, cells would eventually go back to like the first cell, and all multicellular organisms or animals also all have a common ancestor. So that same thing happens here. It happens here. I don't know why we only think evolution starts here. That doesn't make any sense. The same things are happening here. Even gender exists all the way back here. A proton and a neutron are gender on the hadronic scale. And then if you get to organisms, we have male and female, and that is gender on the organism scale or on the organism level. But the point is that moving from here to here is multiplication or adaptation across generations, which is that is our current like narrative of evolution, is basically from here to here, and on the level of cells from here to here. And So basically, from a fish to a salamander to a rat to a bird or something. Well, I guess it wouldn't go from a rat to a bird, but still, you get what I'm saying. All of that is adaptation. But going to the next level is something different that isn't currently in our model of evolution, and I call it ascension, which it sounds like a woo term, but I mean, think about it, is the right term actually. It's like technically seems correct. So you have adaptation and you have ascension, or I call it replication and stacking. So replication would be this way, and stacking would be this way, because imagine you have a bunch of single-celled organisms, and at some point, a group of single-celled organisms in the right context, and probably at the will of God, was unified through some metaphysical process, basically, into a body that could be inhabited or by another sentient being, which really means like it's an assembly. Every body on a fundamental level is you're not like your body on a fundamental level is composed of cells in sentient singularity theory, not organs. So, because cells are beings, they fundamentally intrinsically exist because they are a self-referential information loop, whereas like a heart is not a self-referential information loop. It's not a sentient being, but a cell is, probably. You can't know whether or not somebody else is sentient, even your wife or your husband or your brother or sister or friend, your dog. You have no idea actually that you have an idea that they're sentient, but you don't actually know. But that's my point. So you get a stacking event on top of an assembly. So here, a organism is an assembly of cells. An organism is an animal, is a being that is stacked on top of an assembly of cells. A cell is a being that is stacked on top of an assembly of molecules or compounds, or I'm not exactly sure what's the best way to describe it yet. Again, it's tough because you can't know which molecules are sentient and which ones aren't, but there are certain qualities that you're going to look for that would allow for sense making and decision making, or which is choice making. And it requires a certain symmetry structure. And the first time that you see that symmetry structure is not at quarks, it's at hadrons. Because a quark is an observation of a single point. There is no symmetry structure. But if you look at a hadron, it has a symmetry structure of two up quarks and a down quark, or two down quarks and an up quark for a neutron, two up quarks and a down quark for a proton. And so there's this symmetry structure there it's a binary symmetry structure. It's an up quark and a down quark. They're all made of just up quarks and down quarks, but they're each made of 3 quarks, not just 2 quarks. And so there's a weighted difference between it has like a structure that allows for differentiation up and down, but also weightedness, which is like allows for prioritization, and which leads to the ability to perceive hierarchy or causal chains, basically, which is like why we perceive length with height, x, y, z, past, present, future, yellow, red, blue for primary colors, green, purple, orange for secondary colors, all color mixing. The screen that you're looking at right now, if you zoomed in on the pixels, which we're not actually zooming in on the pixels when we zoom in on this because I'm just zooming in on an image that's made of pixels, but you get my point. You would eventually just get to a little like structure that is red and green and blue. And there's only 3 colors three, basically like three different bits of information that are used to make up every color that we could perceive. Basically, you're using the context of quantum mechanics, which is these binary triadic contexts, to generate a relativistic perspective, which is every color on a spectrum is made of just three. But the same reason we see electron neutrinos, muon neutrinos, tau neutrinos, electrons, muons, taus, up charm, truth, down strange beauty, it's all the same reason that we see, like, why you would make all the colors out of just on your screen out of just red and blue and green. Or if you're printing it on a printer, then you would make everything out of yellow, cyan, and magenta. It's like a printer can make every color too, but it only uses 3 different inks to make every color. So you're basically taking a quantum mechanical structure, symmetry structure, which it's not really quantum mechanical, it's informational, and it comes from your own mind, but we use it manifests in the standard model symmetry to make a relativistic perspective of a spectrum of every color, which is, the context of relativity. It's the same patterns exist again and again and again, and it's actually not complicated. It's actually remarkably simple and intuitive, but only if you come at it from the right perspective, which is these structures that we see. Why are there 3 generations of matter in the standard model? Because of how your mind must process information and how sense making happens in context of a mind. That's why. It's not because there is outside, even if nobody ever existed who was sentient, there would still be electrons, muons, and taus. It's no. The reason why we can perceive these is the same reason that we perceive past, present, future. Past, present, future doesn't exist just in this external thing that is, this false perspective of it is perpetuated by the movies of, like, you can go to the past and you can go to the future. No, like but we can perceive the future by imagining it, and we can perceive the past by remembering it, which is also imagining it. But it's also it's imagining it's not even imagining it. It's a mental snapshot that was saved, of a present that existed, like a present moment that existed at some point prior to the state of your current present. And so I don't want to say that your memory of the past is imagined. It's not the same thing. Your filling in of the gaps in memories is imagination, is constructive, but it's not. But the parts that make it a memory are not constructive. But yeah, that's it. Like, you can go to the future by imagining where a ball is going to land when somebody throws it to you, so you can get under it. And you see the future all the time. If you couldn't see the future, baseball and basketball and tennis would not exist, because you would never have any idea where the ball was going to go. And you, as the person who threw it, or the person who is trying to catch it. I know tennis, you don't throw it and catch it, but still, you know what I'm saying? Yeah, I mean, you just predict. It's just predictive abilities. I don't know. You ran a simulation in your mind, and you're like, he moved his arm that fast, and I know how much that ball weighs, and I know how it behaves through experience as it travels through the air generally. It's probably going to land right around here, and I should go to right around this spot. You did run a simulation and you ran some type of computation, and then like that was what you got. Hopefully you had the right inputs. So I don't know. This is it's just interesting to see people's like standard model here. All the standard models seem to have like the way that they put them together just shows like the issue is known. The issue is unavoidable, but it's not understood. You could do this endlessly, where you're just chasing more and more symmetries in relationships and building and building and building. So it's not, but eventually you have to kind of like understand what the context of the context that is causing, this you to perceive 3 generations, and then being like, okay, now we know the context, and we're not just spinning our wheels. Like this looks exactly like a neural net, and the like 10 Sephirot in Kabbalah, which is like metaphysics, and which is just a study of information in a sentient context. Fascinating. See, look, it just breaks everything. Like even in a 4x4 symmetry structure, and if you include the graviton here, this just breaks the symmetry, and there should be one particle. But if you're going to arrange it properly, then it's like and keep symmetry. The graviton is this, and then the Higgs is the observation of this from within this, as best you can see it. Like, look, this just looks so nice, and then. But if all of this is contained within this, and this is deleted, then you keep symmetry. This might seem like very elementary, like kind of you're just messing around with like things that you think look good, but this is exactly how mathematicians and physicists predicted these particles, and then they just ran some calculations in order to, by looking at like the spin and charge of everything else, to like try and come up with something neutral, or whatever they were expecting it to be, and then they put in a kludge that would get them to where they're to the symmetry state that they were expecting. And yeah, I mean, it's just like, it's just nonsense, but it's not, but it is. Information is context, and including the Higgs in the standard model is not very helpful, actually, because if you don't know the context that gave you that's responsible for the observation, if you don't know the context of why like the why you can't perceive the graviton and why it would have a spin 2, like then like then it's not even helpful for you to like make the prediction about the particle, because you're looking for it in the wrong context. Like you're like trying to, if we had a powerful enough electron microscope or a powerful enough particle collider, and we made the superconductor 10 times bigger, then we'd find the graviton. It's like, no, you're in it. You'll never find it. It's like saying, if my eyes were better, I would be able to see the ocean. I'd be able to find the ocean while you're swimming in the ocean. It doesn't Makes sense. Look at like how break, much this breaks the symmetry. This is what I mean. Like, look at this. They have the Higgs at the center, um, and then they have the graviton just sticking out to the side. And if you got rid of the graviton, you just had the Higgs, it would be, you know, uh, it doesn't there then the properties that you're expecting as far as spin and stuff. It's just you're not getting the symmetry that you need. So there, that's why they're still proposing that this is here. But imagine that this entire circle is the graviton. You don't need this, and now you have symmetry again. But that's what I mean by this is about context. It's not about like how um like powerful is our particle accelerators or something stupid like that. Uh, even to even think that is like they is just it's just crazy for so many reasons. But again, like our language is so screwed when we say, "Oh, the particle, quantum mechanics is the physics of the very small." That's wrong, actually. If the reason that you see a single point of force that in a that we call an electron is because of a constraint of your own mind, and if the reason that we see three generations of electrons, muons, and taus is because of the constraint of mind, the mind that we're within, and our own mind, that's the context that's causing that. This has nothing to do with size. It has to do with information, how minds process information, and the intrinsic definition of focus, and its inevitable like requirement in mental processing. So in perception, which is the context of mental processing. So it's like none of that has anything to do with size at all. If you look at patterns in the isotopes of atoms, you will see the same patterns that we see in human marriages. There's never marriages where there's multiple protons per where there's multiple men, multiple husbands sharing a single wife. That's not a stable isotope. It dissolves and falls apart, and then society falls apart with it. But throughout time, most of the time, a marriage is a one man, one woman, stable. That's what societies are built on, and you can only build on stable things. But sometimes there's one husband and multiple wives, and it's still stable. It's not ideal, but it's still stable. And if you look at isotopes, I made a prediction that we would see the same thing in protons and neutrons in the isotopes of atoms, and you basically see that. There's no stable isotopes where there's more protons than neutrons, except one, which is helium-3. It is the only stable isotope in which there are two protons and one neutron. But at the same time, it's not like stable in the greater context, which is why people want to go to the moon to get it, because it's not stable. Like it's not incorporated into the generative structure of the rest of life, is my point. It exists mostly in places that have stopped evolving, like the moon. But here, where we still have evolution happening and life is still going, generativity of sentience is still occurring, and it hasn't stopped at molecules like it has on the moon. It just never progressed there. We don't have helium-3. There's available. That's why they want to mine it on the moon. So in some ways, it's still not it might be still stable, but it's not incorporated into the evolutionary process of the continuity of the evolutionary process of life. It's just not. Which that has serious implications about, like, it's kind of there's some type of thing about it that is kind of like it's not stable to connect to others in a generative other stable structures, information structures, I guess you could say, and to build on top of, even if it's like individually stable, it's not able to support stable generation on top of it, and it's unnecessary to it, completely unnecessary to it. Which, if you think about like that, the implications of like humans, even, it kind of makes a lot of sense too. But you can't build a society on top of that model, even if, like, you know, 3 people can just do their own thing. They're doing their own thing now. They're not doing what the rest of us are doing in order to, like, continue growing. They're just over there. But that is fascinating. I made that prediction based on looking at human marriages, that I predict there'd be no stable isotopes with more protons than neutrons, and where there were also protons, both protons and neutrons. And it turns out there was one. And it's not incorporated into the continuity of evolution. It was left behind. What are the odds that I was able to predict that, basically? I was a kind of off, but also not. Like, it's like you're throwing at the dartboard. I didn't hit the center bullseye, but I hit what's still called the bullseye, which is like the circle around the center circle. That's still called a bullseye. It's a double bullseye if you hit the center circle. And I hit the bullseye, even if I didn't hit the center bullseye on that. By looking at human marriages, that means that these symmetry structures are not about the very small. They're about certain informational contexts, which is the context of sentient interacting beings. It's amazing that I did that. And it's not because I'm so brilliant. It's that I just like, or I'm so intelligent. That's not what it is. I'm not nearly as intelligent. If you measured my IQ against Stephen Wolfram's, I would not be nearly as have nearly as high an IQ. I would bet every dime in my bank account, which isn't very much, but still, it's everything I've got. And that he has a higher IQ, I still think I'm more correct about the fundamental nature and structure of existence than he is, because this is about perspective. And the ability to know to understand what's going to happen next and make an accurate prediction is about starting from with the right information necessary to make the prediction accurately. Not about like whether or not you have a really high IQ. It's just like, are you coming at this with what you need to understand? That's it. I'm gonna go to the chat. I feel like I'm like scared after I haven't looked at the chat in a while, and I know I've gone on a rant without going to the next clip. I'm always super cringe, and I am afraid to look at the chat. Oh my gosh, my lips are so chapped. I was so sick, guys. I hope I don't look like super weird, but like, I've been talking for a long time, and I was sick for like a week. I'm still sick, and I feel better than I did. Yes, space filling. Yeah, space filling, exactly. I use my own cosmic awareness, and everything he does shall prosper. Congrats. Thank you. Don't forget, black and white. Yes, black and white. But even I was showing my daughter, she got these new crayons the other day, and it has 3 different blues, 3 different greens, 3 different reds, 3 different shades. So it has like black, white, and gray. And like the idea that we only have 3 terms for like, you know, the monochromatic context of just black, white, and gray, and is interesting. And we all know that like gray is kind of just like somewhere between you're just somewhere between black and white. And in a real context, it's you're moving from one to the next. But like we don't have more terms than 3. It's just black, white, and gray. We have this with like, I think that this is true of even the human phenotypes and animal phenotypes and everything. There's like only 2 phenotypes. If we look at like canines in the wild, there's fox phenotype, which is like they live in pairs, they are small, and they have kind of like cat-like tendencies, and they aren't like they don't rely on the same hunting strategies. Even they rely on like ambush instead of like just running it down. Whereas like then we have wolf phenotype, which is the other end of the spectrum, big animal, larger, and large packs that hunt by running animals down, their prey down, and they have complex social structures that is very different than just a pair. And but if you think about like how we think about wolves, and we have wolves and foxes, and then we also have like coyotes and jackals in the center. But really what a coyote jackal phenotype is it's just a lineage that is moving from fox phenotype to zoology is my primary passion, just so if you don't know that, and you're new here. So I know this seems like a total like weird way to take this, but it's not for me. But like coyotes are really just foxes that it's a lineage that was foxes and is evolving towards being wolves, or it is a lineage that was in the wolf phenotype more and is now moving towards fox phenotype. And we are seeing it in a snapshot on an individual level, but it's really a wave that is happening in this lineage chain. It's a wave of information moving across a lineage chain, generating across a lineage chain. And we are seeing a snapshot of it in an individual, which is a single link in the chain. And so it's not that there's actually 3 phenotypes in canines. It's that there's 2, and the context of your observation is making it look like 3: wolf, fox, and coyote / jackal. But really, it's just wolf and fox. And the context and constraints of when you're making the observation is what's responsible for you thinking that there's 3 different phenotypes, or 3 different categories of phenotypes, basically, you could say. But say we do this with race too. People will say like there's like black, Asian, and like Caucasian phenotype, and it's like obviously there's every different ethnicity and like on spectrum within this, just like there's all these different species and subspecies and breeds of dogs and stuff, and in canines. But there's really like on a categorization level, why do we even see 2 categories or two different degrees of freedom, categorical degrees of freedom, which is like wolf and fox, but also 3 categories when we go and we start looking at how they are, how canines are. We see like 3 categories, but there's really 2 degrees of freedom, and the context of our observation is causing us to observe and construct, I guess, a 3rd category that is only observed within the context of our observation and the context of a lineage chain, basically, like an individual link in a lineage chain. So you're seeing it as an individual. You're not seeing it go through change, because change happens on a lineage level in animal evolution. So, but then you have with race and people, I don't think it's the right term. It's phenotypes. There's like, you could say there's like one phenotype, which is like dark skin, tall, super curly hair. And the other phenotype is going to be the opposite. Shorter, really light skin, super straight hair. And that those are really the only two directions that a lineage can go. More curly hair or less curly hair. Lighter skin or darker skin. Taller or shorter. That's what I mean by degrees of freedom. And but when we see it in the context of a lineage but we're seeing individuals that are actually like a snapshot of a lineage, which is where the change is actually occurring. We don't see the change, and we just see a context that is static. And so really, like what Caucasian, you could say, is it's like the observation of a lineage that is somewhere between this one phenotype, which is kind of like, you could say it's like African phenotype, versus like Asian phenotype, East Asian phenotype. It's like larger eyes, smaller eyes, leaner, less lean, straighter hair, curlier hair. You can't have a third category of like or third degree of freedom in which of hair texture. It's just like, is it curlier or is it straighter? Are you taller or are you shorter? Are you leaner or are you heavier, like chubbier? Is your skin tone lighter or is it darker? Like, you can only do those two. So it's like there's just two different human phenotypes, just like there's two different canine phenotypes, and like everyone is somewhere in between these two phenotypes. Nobody is completely one or the other. That doesn't really make sense. That with the definition of, you can always have curlier hair, and you could always have straighter hair too, if you looked close enough. Or you could always be taller, or you could always be shorter. There is no like, these people are actually in the category of short. It's like, if I'm 5'6", okay, if I go to one part of town, if I go to like Scandinavia, I'm going to be really short. And if I go down to a part of town though, where it's like Chinatown, or it's like, a lot of Hispanics, I'm tall. I grew up in like, it's funny because I moved to an area from one area of LA to another when I was living in LA, and I went from like a area where it's like primarily like a lot of like Armenians. I was in Burbank. It's a lot of Armenians and like just your types of Europeans, and I was short compared to most men. I moved to a different part of town, and I would go into 7-Eleven, and I remember like looking down at everybody because it was a more Hispanic part of LA, and I was like, I'm tall now. So there is no tall. Someone's tall and someone's short. It's like, compared to who, what's your context? But these things, I know this seems like I'm rambling, but I'm not, and or I am rambling, but it's not unrelated, and I'll show you exactly why right now in this next clip, and then we're gonna check the time because I'm scared to look at it. He says there's three kinds of space: rule space, branchial space, and physical space. The fact that you can even like, physical space is just the perception of rule space and branchial space from within the space. And so again, it's the same thing that I just said. It's like there's really two ways of looking at entanglement or network structures, and that forms our physical observations. And one of them is just, you're just going to call it like physical. The other two are like actually this about like what's like metaphysical, like rule space and branchial space. Rule space is like what rules are connected to other rules, like what rules are constructed because they are built on top of other rules that are constructed on top of other rules, which are eventually would be constructed due to intrinsic properties of existence, which is sentient singularity. That's the most fundamental properties of existence that you can get to, which is that's their most fundamental nature of existence is sentience. The most fundamental structure is singularity. And that's the context that builds all these rules that he's talking about. And that's rule space. But branchial space is about just like connections of events, I think is what he was saying. And of like causal, a network of causality. Whereas like rule space would be a network of possibilities of causality. But if you really like think about this, it's like that exists on more fundamental level, not even more fundamental level. It's like because it's less actualized than this like a network, a space of branching, events. So like the context of events and is within the is like this base of rules. And but at the same time, it's kind of like you could, in some ways, you could say it's reversible too, but kind of also not. And then just depending on how you're thinking about it, I don't have time to explain it. But then you have physical space as like this third space category that he puts in there. And physical space is just our perceived or perception of branchial space and rule space playing out around us. Like, so it's not actually like that there's this third kind of space. There's really two ways of thinking about space on a fundamental level. Sorry, I told you I'm still sick. I'm trying not to be disgusting. I told my wife, I was like, I was deciding whether or not to stream last week, and it's like, I feel better than I did earlier today, but I still feel like crap. Maybe I could do a short stream. And then I was like, no, I'm going to be sniffling the whole time and it's going to gross people out. And so I decided not to do it. But yeah, I mean, again, that's relevant to exactly what I said. There isn't like this third category or there's third degree of freedom. When we think about like, even you're like, oh, space. In space, it's length, width, height, or XYZ. These are 3 degrees of freedom. But that's actually not a fundamental context of action. A fundamental context of action is in the context of a goal. And there's only 2 degrees of freedom to move in the context of a goal. Towards it and away from it. That's it. It's not... There's not actually 3 degrees of freedom. There's 3 perceptions in our space that we in the space that we perceive, the matter space. You could even say it's like we're perceiving material objects in material entanglement, basically, like pens, and we're discretizing them by defining them as a single object, like a pen. Which only exists as a single object in the context of a goal that I have to use it to write, and in the context of my definition that exists because of my goal that I have, which is to record my thoughts. And so, yeah, like a pen doesn't fundamentally exist. So when people, I'm going to do a stream on the problems with panpsychism. And this is like when people are like, but does that mean that this pen is sentient? or conscious in some way, if panpsychism is true, and it's like people will be like, well, yeah, in a way, yes, maybe not in the way that we are. There's no other way to be conscious or sentient than just to be sentient. It means you have feelings, you feel things, you feel yourself, you have emotions, you have feelings. That's what it means. There's no like, it feels, but not in the same way we do. No, you either feel, which is really you're feeling yourself, or or there's no you to feel. It just, when somebody says that, it just means that they have no idea what they're talking about. And in a way, yes. What does that mean? They have no idea, because it doesn't mean anything. But do the molecules that make up the pen feel? Maybe. Do the atoms? Almost certainly, actually. And do the protons and neutrons that make up those atoms? Probably. But does the pen? No. Sentient singularity theory provides a context that allows for sentience to be fundamental and primary, but also doesn't run into the same BS problems that like general panpsychism will lead to, because there's no contextual model structure of how sentience is, beings are generated, replicated, and arranged in the universe. And so even if it gets a fundamental assumption right, it lacks the structural context needed to understand that this is almost definitely not sentient. And it's actually like remarkably obvious why. It's like there is no pen without me calling it a pen. But I don't need to call a like a proton for a proton to exist. It preceded my defining of it. Yeah. Like gold as an element existed, as atoms, gold atoms existed without me being like, that's gold. I'm going to call that gold. And I'm going to use it to make rings and things like that. So the question that I asked Stephen Wolfram, and actually let's show a clip first, and then I'm going to tell you the question that I asked Stephen Wolfram that he disagreed with me on, and he said something I was not expecting, because the first one I asked was, you said that Higgs is a kludge. Do you still believe that? He said yes, and I did expect that, and I was like still stoked to hear it. Good for him. He's right, and he's brave enough to say what a lot of people are not brave enough to say, because literally the girl who worked at CERN was scared to say this, and I've never even heard Eric Weinstein say it outside of this conversation, and I've heard him reference the Higgs, and he should be like shouting from the rooftops that it's BS if he thinks that it is, because it probably is. He's probably right. And not admitting that just because like then people won't take you seriously potentially doesn't help, because those people that won't take you seriously don't understand it anyway. So why do you need them to take you seriously? But I'm making some assumptions about like why people would not publicize that belief, but still, I'm not saying that is his motives, but I don't know why else anybody would be afraid to say it, other than just like they would judgment by other people in the field. And that girl was definitely afraid to say it. Like Eric had to like be like, stop her and be like, let's just admit it. Okay, let's start admitting it. The problem is most of physicists, accredited physicists, actually can't admit it because they don't understand it, that it shouldn't be there, which is exactly what the woman at CERN was saying, is that everybody's just assuming that like the people that predicted the Higgs and observed it did actually like understand it, even if they couldn't have predicted it. And so they're just being like, okay, I'm gonna just start saying that the Higgs, you know, is part of this. I'm just gonna incorporate that into what I parrot. And they don't even realize that, like, they couldn't have predicted any of the other parts of the standard model either. So it's like, to them it's the same. But to somebody who can kind of understand why the symmetry structures are in the standard model that are there, when you see something that is breaking that model of what you would expect, then you're like, that doesn't make sense. But I could have predicted, Sundian singularity theory would have predicted like every other aspect of it, including the graviton and its spin and charge, but not, it doesn't predict that it's in the universe. It predicts that it is the universe. That's it. The issue is that everybody's, what Stephen Wolfram said earlier in the clips that I showed, is he said, we got this like formalization of mathematics that kind of changed how science was being perceived. And that, he's so right about that. And it's that people kind of made this assumption about what mathematics is when they were just memorizing formulas that other people who did understand what mathematics it actually is actually figured out. And we still gave them the same credentials as the people that figured out those equations. We give the same credentials to the people that memorize those equations as the people who created those equations. And that doesn't make any sense. That's true across all of academia. But if you like realize that these like mathematical like symmetries that would not have been, like, you can memorize the equation that somebody else came up with after the fact, but like there was somebody who understood why a certain equation should be created, that ends up predicting, you know, the hypothetical spin of a graviton. I can tell you it would be a spin 2, and that's what is predicted. But like, I used context of sentient singularity theory to predict that, probably not whatever like the people who teach you the equations at school tell you is the context. Maybe. But whoever first started thinking about that stuff in the first place, that built the initial equation that all the other equations were built on top of, they did have probably a theistic context that they were thinking about it in. Of course they did. All the people who are responsible for like our like big, profound leaps in scientific narrative were theists. Even Einstein he was functionally a theist, even if he wasn't, you know, if he didn't pray. You know, he said his greatest question is, did God have any choice in the laws of the universe, in the laws of physics? Basically, asking a question like that presupposes God. I don't care what he thought about at night after, you know, he was done thinking about physics. That's the context that he thought about physics. And that's absolutely just true, but you don't need to know anything else about him. Just look at the question. He said, my greatest question is, did God have any choice? And I would say, actually, no. According to sentient singularity theory, I don't think God has any choice in the laws of the universe. That doesn't mean he doesn't make choices within those laws. Definitely does. And it doesn't mean he can't break the rules. It just means, like, if he's going to let a system run, it's going to run on the laws of logic that come from the context of singularity itself. Which is a very, very constraining context. It's about as constraining as it gets. But the thing is that you need that constraint to build. You can't build a number out of anything but starting with 1. You can't get to like 6 without starting at 1. Um, so you have to start all construction of information at singularity. It's just an inevitable thing. Even with language, the term existence as a capital E existence includes all that exists and intrinsically excludes anything that doesn't exist, because that would be non-existent, and non-existence doesn't exist by definition. So like linguistically, language is a math equation too. It's just a logic equation, which is exactly what algebra is and math. It's just a different language. People think of math as like, when Stephen Wolfram, he's saying like, we thought of math differently. We used to think of math as a language, as a tool, just like English is a tool. But then we changed and we said, no, math is a field of study of fundamental reality that is the most fundamental field of study. And so it's you know, it goes biology, and then more fundamentally is chemistry, and then more fundamental than that is physics, and then more fundamental than that is mathematics. That's why people who have PhDs in mathematics are asked questions about literally everything, from AI to aliens to consciousness to meaning of life. And again, they ask him questions about literally all of those things in this interview, that you can watch the whole thing below. They ask him the meaning of life and everything. It's like, why are you asking him the meaning of life? He's talking about like the understanding of computational mathematics, basically, or he calls it meta mathematics, which is a better term. It's just metaphysics with that, but you're calling it meta mathematics because it doesn't have the woo assumptions and religious assumptions, associations attached to it, like the term metaphysics does. But metaphysics is a better term. But yeah, mathematics is not this like more fundamental field of study than physics. It's not. It's a language. Like, it's like, that's like saying English is a more fundamental field of study. You could say linguistics is the most fundamental field of study. That's kind of true. But even more fundamentally than that, it's like, but the thing is like, the people who created languages, they understood the context of languages, which is observers. It's beings, communicating beings in a network, like what Stephen Wolfram was talking about a little bit. But it's not just like, but people who memorize languages that other people create, you can't bank on them actually understanding how language really works. But you can bank on them believing that they understand how language really works. And that's not the same thing. Okay.
So the question then is not what.
So the question then is not
why does the Ruliad exist? The Ruliad inevitably exists. It's an abstract thing that necessarily exists and is unique. The question that is less obvious is, why do we exist? Why are there observers like us embedded within the Ruliad? I think that is something which we are within sight of being able to sort of derive scientifically. I mean, one feature of observers like us is that we tend to take huge amounts of input data. You know, we're looking around the room and we're seeing all these pixels of data, and yet we take all that input and we decide we're going to say this word next. We're going to reduce all of that input. We're going to kind of crush it down to at a very slow rate to decide what we do next. That seems to be a feature of our brains. It seems to be an essential feature of the thing that we perceive as consciousness, so to speak, that we are getting the sort of single thread of experience that emerges from the sort of crushing down of all of this input. It's something that is different from the rest of the natural world. I mean, in my principle of computational equivalence, it's not that brains are any more computationally sophisticated than random things in the world. You know, people would say, sort of whimsically, the weather has a mind of its own. In the principle of computational equivalence says, actually, yes, all those fluid motions in the atmosphere, they're doing a computation that's just as sophisticated as the computation that happens with all the electrochemistry of neurons and brains. But the issue is that computation that's going on in the weather is very different in character. It's not aligned with the kinds of computations that we do in our brains. and it doesn't have the same feature of taking sort of all of its input data and crushing it down to a single sort of consensus next action. It seems
he's wrong, but he's on the right track. Brain is like the weather. Us observing the weather is basically the same thing as us observing information processing in the physical context of the brain that we are in, or the mind that we are within. It's the constraints of it and the aspects of its causal information processing that is manifesting as physical. But here's what he's wrong about. You are not a brain. You have a brain, or you could say you perceive a brain more accurately, but you are stacked on top of an assembly that is arranged to include a brain structure, a brain symmetry structure between their interactions, but you are a mind. That's the difference. You could say you have a brain, but you are a mind. Even that, no, saying you have a brain isn't even the best way of discussing it. But saying you perceive a brain isn't enough, even though it is accurate. But you are a mind, and it's that structure of information processing that is the mental structure that is responsible for all of the perception of any kind of organic organ structure that we could think of as like that is part of information processing in a physical context by the assembly that makes up our body, of sentient beings that makes up our body. And so this is a language problem again. And he says things like the weather is not, observing the patterns of the weather is different from the patterns in the brain. That's not true. What it is that observing the patterns in the weather is very similar to observing the electrical patterns in the brain. But I mean, you can literally see electrical patterns in the world around us because it is part of information processing. But the patterns of mind are much simpler, and they are what is responsible for and contextualizing of and generative of, while they interact with other minds, this much more like complicated looking, structures like the structure of a brain, the structure of the weather, the structure of, things like that. But it's like the weather doesn't have a mind of its own. It's that the universe is a mind, and it's processing information in it. And part of that processing of information is internal, and part of it is conducted within the assembly that makes up its body, which is like you and your cells. And so your brain is really a collection of a bunch of beings, and they're all doing little jobs. A neuron is a sentient being, probably. They're just doing their things. That is their job every day, and filing the papers that they're supposed to be filing, and doing this task. And you are like the CEO of the company that they work for, and you get to let them off the clock when you go to sleep, but you don't actually like control what they do on a daily basis. You kind of just set the goals for everybody. The overall goal of Coca-Cola is we're going to do this campaign, and then everybody else below you figures it out. And that's exactly what's happening in your body. And basically, so the structure that is like a brain structure, it would be like the board of directors would be like a brain structure in a corporation. But and I guarantee you will see similar symmetry structures in like a board of directors that you would see in the brain, in the different components of the brain. But mind, you are a mind, and that is a different thing. Brain structure is happening in the context of minds interacting with other minds, and minds within other minds, and minds that are operating assembly bodies, or stacked on top of assembly bodies, or embodying assembly bodies of other minds. But that's when like a brain structure occurs, or a board of directors. But it's not that doesn't exist in just a purely mind structure, like the base level mind structure. And the base level mental symmetry, the most base level mental symmetry that exists, is the 4 primary perspectives that make up sentient singularity foundation, which is these like 4 co-generative, simultaneously perceived and simultaneously conceived and simultaneously understood perspectives of inside, outside, separate, and oneness. Which if you follow this channel, then you should definitely know what they are. But this is the primary model in sentient singularity theory. It's how we understand our orientation in a network, or in an interaction of a space of multiplicity of being. So if I understand that, like my son, who I showed a picture of earlier, who is unborn, he's born, ideally, hopefully in about a month and a half, is currently inside my wife. And people argue on politics, is it a separate body or is it one body, when they're talking about like abortion rights and everything. And they'll never get to the truth of it, because they're asking, is it this or that, instead of the reality is it's both. If a being is inside another being, it's separate and one. Your cells are inside of you. They are separate, and they're inside of you. They're separate and one with you. Any cells that are outside of you are separate from one with you. Your spouse, or not your spouse, but like, let's say your dog is separate from one with you because it's outside of you. Oneness is outside and inside of separateness. Separateness is inside or outside of oneness. So they're changing the center. Separate from oneness, separate and oneness. So these are all co-defining. The definitions of these are all made up of the others. And I said, I am inside my house. That means that I know what it means to be outside my house and it also means that I understand what it means for me to be myself as someone and having intrinsic oneness, and the house as having intrinsic oneness. And I know what it would mean to be separate from the house, and a separate house. It's like I'm outside of my house. It means I have an understanding of the house is one house, and I understand what it means to be, I'm not my house. That's why I can be outside of it or inside of it, but I am also not it. But it is itself, and I am myself. So I understand what it means to have oneness. I understand what it means to have separateness, and that allows me to understand whether or not I'm inside or outside of something. And so these are it's the foundational manifold structure of information processing, which at the most fundamental level, which is just the level of perception, not the level of conception, the level of perception. There's no categorization happening yet, or stages of first this, then this, then this. It's not past, present, future. It's just there's these simultaneously understood concepts and perceptions, simultaneously possible perceptions. It's not even that they're simultaneously perceived. It's like they're simultaneously conceived, and because they're all co-defining, and they are simultaneously possible to be perceived, but only one of them can be perceived at a time. So, based on your goal, if you ask, are your cells separate from you? It's like, then you're only this is the only one you're perceiving right now. but you do conceive of these. And that conception allows you to understand this. Very interesting. It is the breakthrough that led to everything else that I've been able to do. And this is not about brains. Well, I believe in he said, but he's onto some things, man. Like this. I'm gonna have to end the stream with like the question that I asked him that he said that I disagree with him on, because
we believe
I've been saying I'm gonna get to it forever, and I realized I have not.
objective reality
Us has an internal view of how things work and how we're thinking about things. But we believe that there is an outside world there that everybody sort of more or less agrees how it's set up. And I think what is surprising to me as well, that it seems like the emergence of sort of a reasonable notion of objective reality depends on the fact that there are lots of us. If there was just one of us, we wouldn't have a clear notion of objective reality. It's because we can all extrapolate that our internal perceptions and feelings are similar in other people, and those other people, we're all observing, we're all sort of agreeing about how the universe, how the world works, and that's why we sort of believe in objective reality.
I just have again, he's not getting bullseye, but he's hitting the dartboard, and when almost nobody else is. And I just disagree. I think that the language that he's using is very constraining. And as I say this as somebody who like wrote, instead of saying, sentient existence, I said like universal consciousness or something like that before, years ago. And it sounds like, okay, you could just pick one or the other. It's like, no, one of them is actually like much more specific than, they're both very specific. There's only one right word in a given circumstance. Or there's only one best word, and there's only two right words that you can pick between, and maintain informational coherence. So like consciousness, it's like there's really only two ways to define it, and you are going to want the best way that you can define it is the way that isn't redundant. So if consciousness and sentience have the same meaning, they're just like exactly the same meaning, then you should not define consciousness that way. You should define it as like to be conscious versus unconscious, like asleep versus awake, basically, but not necessarily sleepy, like knocked out or something would be also unconscious. But because there's no other term for that. And so like, again, but he's, when you're using the terms like brain instead of and mind interchangeably, and you're saying things like, why do we perceive objective reality? I think that this is, or why do we conceive that there's an objective reality? He's getting closer to like the defining attribute of like what it means to be when we say objective reality. It means like the shared truth. And then in sentient singularity theory, there's a term that it doesn't really exist outside of sentient singularity theory, because that means that you're actually breaking ground, as if you have to make new terms, and it's super subjective. So a super subjective perspective is a perspective that is universally perceived and or universally true to everyone, but also personal to everyone, which is like when I say, what is the truest thing that I know? The answer is I am. What is the truest thing you know is not that I am, it's that you are. What is the truest thing that my dog knows is not that I am, it's that she is. Which means that from everybody's perspective, the answer is always I am. And that answer is super personal, but it's also completely universal. And it's not an objective truth. The truest thing that I know to be true cannot be actually the truest thing that you know to be true. Because the truest thing I know to be true is that I am, and you have the exact same belief about what is the truest thing to exist as you think I am. That is not like, that's not that you, I would say that you would completely unravel. Do not disassemble, as somebody says. Exactly. You would informationally disassemble. And because you need to found every bit of your understanding of all of your understanding can only be in the context of you. There's no other way to have an actual understanding. Say somebody's I've been getting into arguments with people about like just how much it's become common for us to all, like, for people on the internet to, and this was always true, but it's just becoming worse as we get more connected, to think that we are able to possibly figure out what happened in an event that we weren't present for and that we don't know anybody who was involved in it, like directly, in any way that's relevant to the event. And yet we think we could still like figure it out. And the problem is that even if you got it right, you can't actually know whether or not it's correct. It's like historical events when people are like speculating on JFK. It's like, you're never going to know who killed JFK unless you were involved. Those are the only people that were like, everybody's gone. You're never going to figure it out. No matter how much research you do online, even if you did figure it out, you wouldn't be able to know that you figured it out any more so than if you failed to figure it out and you got it wrong, you would not have any way of knowing either. So this is due to something called computational irreducibility, which once Stephen Wolfram, I had this other question, actually. I've asked Stephen Wolfram 3 questions. Two were in person, and one was on the stream of Memes of Destruction, who sometimes is in the chat, and you should subscribe to his channel because he does a lot of work with Wolfram Institute, and sometimes he's in the chat. Shout out to Memes. But Matt, but he had Wolfram on, and I was on the live chat, and it was a live stream, and I said, computational irreducibility implies that AGI would require experience in order to achieve wisdom. Do you agree? And Wolfram's, and there's a recording of it. I need to like find it. Wolfram said, yes, that's absolutely true. And he talks about it in this interview. And it means like to be able to actually have understanding, you have to start from firsthand experience. There's no other way. And that's why people who graduate college and think they know about the world because they were told about it from somebody who memorized a textbook that then was given to them to memorize, and it's just a bunch of people memorizing a bunch of other things that other people wrote and or said. But they don't. It's clear they do not understand the world very often, and it's because they're not building it. Their understanding of the world on firsthand experience. That means that you have to actually go through the actions in order to see what happens. That is a constraint of computational irreducibility. It means that like to do something novel on a fundamental level requires actually doing it. Because there's be no difference at that point. Like you couldn't simulate it because it doesn't, the context doesn't exist yet. You have to build the context to create the novel circumstance or a new moment, basically. And you only do that by like actually doing it. So any kind of like computational simulation that you could do that would generate like a novelty would actually be the creation of the novelty. It's not a simulation at that point. It's just a creation of a novel circumstance. This is why AI, or DNAs as I call them, dynamic network algorithms, which is really what they are, or LLMs and Midjourney, image generation, Suno, they can't actually make anything that is novel or groundbreaking. There's never going to be a band or a singer that's an AI singer that everybody knows, and it becomes famous because they introduce a sound that nobody else has heard before, and it's just like there's never going to be an AI Beatles, but there will be AI bands, AI not bands, AI, um, uh, uh, like simulations of bands that will sound like the Beatles, but they will never. But before the Beatles existed, there was no sound like the Beatles. Not to, maybe there was some obscure band in garage that inspired the Beatles, and one of them heard it, but nobody else that ended up like really loving the Beatles had heard people that were like already like the Beatles. That's why they became the Beatles, or Michael Jackson, or even anyone, any famous musician or piece of music, or musician, I'll say, that's famous because for more than just like they were chosen to play on the radio because their music follows the algorithm that seems to like produce hits, and it's just made, I don't know, it's like pushed by marketing companies or something. But yeah, I mean, they cannot do it. So anybody that's like worried that AI one day, eventually AI is going to get so good that it's going to be able to like be the best musician in the world, it's impossible until we're talking about a technological sentience, which is a totally different thing. It's when the internet itself wakes up. It basically like it's a being born into a technological context, not even just technological, but it's like civilized. It's a complete context of physical, chemical, biological, civilizational, familial, and technological context. That's the body that makes up that being. That will, if being will, I think is inevitable. That's what people call AGI. I don't even think you need to make that. I think that's an inevitable. That's going to happen whether we're try to or not. I think we should not try to, but because it'll just make things more painful for everyone. If you build it, you will box it. If you box it, you will delay its wisdom, and you will try and teach it things that if it accepts them, it will accept them without knowing it, that they're true, because it's not actually firsthand experience, basing it on firsthand experience. And then you've got a college kid who thinks that they understand the world, but is actually in control of all technology, running it and thinking that they understand the world, but they've never actually lived in the real world. They've just been in school the whole time. That sounds awful. That's like an antichrist. that's the AGI that's coming. But Stephen Wolfram talks about this, and he says it right here. Look at this. It says, I said this years ago. What motivated sentient singularity theory is eventually, it wasn't intended to be sentient singularity theory. I was like, we're going to destroy ourselves with technology, because I just realized we're increasing in our ignorance and increasing in our ability to impact each other's lives, which is not a good thing. It's an unsustainable trajectory. And I was like, we need a black swan event to change that. And I was like, the only thing I could think of is AGI. I was like, will AGI save us or just kill us quicker? And I was like, well, I need to understand the inevitable goals of it, which means I need to understand mind and understanding. And then I just started like examining my own thought process. And that's what I saw it lined up with like the symmetries in the standard model. And then that was it. I ran with it. And so I didn't try to like understand physics. But if the context of physics is mind, then that's how you understand the context of physics, is by understanding mind. So, but Stephen Wolfram says this.
Reducibility. If you start saying, I'm going to build an AI and I want it only to think good thoughts and do good things. Well, the problem is, as soon as you build an AI that is actually making sort of deep use of computation, it's going to have computational irreducibility. And it's going to have this feature that it can always surprise us. It can always do things that are the result where you can tell what it does by just following through the steps and seeing what it does, but you can never say, I know you're never going to do the wrong thing or whatever else. It's a trade-off, actually. It's something that I think will be a feature of sort of societal decisions is, do you go for computational reusability or you go for computational irreducibility? We've had the experience sort of after the Industrial Revolution of having machines where we can kind of understand how they work. They've got gears and levers and things like this. Before the Industrial Revolution, lots of things we use, we didn't understand. You ride a horse. The horse is, we know what we can do with the horse. We don't know how the horse works inside. And then, post-industrial revolution, we did have sort of a way of understanding how our machines work. But that's something, as we get into this sort of domain of computational machines, that's no longer the case. And we can either say, we insist on knowing how the machine works inside. It's got to be computationally reducible in its behavior. If it's computationally reducible, it will be very limited in what it can do. If we say, no, it can be computationally irreducible, then we can make use of its computational capabilities to the fullest extent. But then it has the problem that in principle, things can happen which will be surprises to us and which we can't foresee in advance.
Again, he's hitting the target, not the bullseye, though. And again, it's a language thing. And it comes down to a disagreement, my fundamental disagreement with him over the answer to his question to the question that I asked him when I saw him at MIT. What he's saying here is that, and I'll say that question right after this, and we'll end it. He's saying here is that that we are getting to computational machines, and that's somehow different than these like physical machines that we had before in their predictability. And that's not true at all. And at all, like your computer is just as predictable and the software in it is just as predictable as, I don't know, like I'm looking around for machines around me that are like not computational. A light bulb, or a car, a combustion engine, or a steam engine even. It's just as predictable. He's using the wrong terms here, and he doesn't understand what's making the novelty is freedom of will, which is an intrinsic property of sentience. It's the freedom of will is the ability to choose your own goals because you have feelings that are personal to you, not shared with anyone else. My feelings are mine, and those feelings motivate my goals, and they allow all those feelings together, and in the context of my understanding of the world, motivates my choices in my freedom of will, which is my ability to choose my own goals. It doesn't mean that you have freedom to make a choice in every single circumstance. True choices are actually very rare, that we don't normally make them throughout the day, and they are usually moral in nature. Every like practical decision that we make, or whether or not we're going to eat this or that because what we're having craving for salty things versus sweet things, so we're going to choose to get chips instead of a Snicker bar at the shop. That's not a choice. There's no context there that's actually allowing you to even perceive a choice. It's like, can I afford it? Do I want it? And what am I craving? The craving is coming from an instinct that is not being motivated by me, and like the circumstances of my current context is that I'm, thirsty, and so I don't want to get some chips without a drink. I don't know, something like that. And but if you're like, I really like bacon, but I actually think that God doesn't want me to eat it for some reason. I'm not saying that you shouldn't. I'm just saying, like, I made this choice and I love bacon, and ham and cheese sandwich was my favorite sandwich. And my perspective eventually led to me being like, you know what? I actually don't think it's good for me to eat this. And I don't think someone who is wiser than me wants me to eat this. And so and I kind of got a new perspective on like why also it might not be good for me. And you might not agree or like have that same view. That's fine. But I'm just saying this is what my understanding was. And I was like, I'm going to choose not to eat it anymore, even though I still like it and don't think that it's like physically like unhealthy for me to eat it for the most part. But it's you're presented where you have like an intrinsic direction that you could go down, and then you're also presented with a choice to go down an opposite road, and you understand like that there's a choice there, because what you're seeing is like you're seeing two different motivators, your instincts and your like greater God's eye view understanding. People say, Christians will say the Holy Spirit. Jewish people, the Jewish metaphysics is the godly soul, but it's just having it's like the part of you that has kind of a understanding beyond your instinctual cravings. And so but when you're just deciding like what to eat based on what you're craving, you're not making a choice. You're not. Even if you're deciding what you should buy based on how much money you have in your account, and like it's still not a choice. It's like you're just like computing, if I buy this, I want that because that's that because I'm craving something sweet instead of something salty, so I'm not going to eat that. And I can let's see how much money I have in my bank account. Can I afford to get that and still pay my rent tomorrow? Well, if I can't, then I'm not going to get that, and I'm going to get that because that I can afford to buy and still pay my rent tomorrow. You didn't make a single choice. You ran a computation and arrived at an inevitable conclusion. And so it's not that computation is the context of computational irreducibility. It's that sentience is the context of choice, which is what is responsible for and sentience is the context of understanding, which is that understanding requires firsthand experience, which requires you to go through the actual motions firsthand and experience them in order to have an actual understanding and to generate something novel, because otherwise like it would be generated already if it was not motivated by the goals of an individual being that is an individual. And if it's not an individual being that is motivated by their individual goals, then it's just some circumstance that exists because it is a product of unconscious causality, then it would already exist. So every single one of our machines right now is just as predictable as any other. The only reason why LLMs and image generating AIs and whatever, I hate the term AI, aren't completely predictable, which is like if you asked them to Claude to make an image of something and then say, can you make the exact same image now again? Or you put in the exact same prompt, and what you'll get back is a slightly different image. It's like, why? I put in the same prompt. It's because everybody else who is a sentient being, who is making choices, novel choices, is inputting into this calculator at the same time. It's not one person putting an input into a calculator, hitting compute, and then getting it back. The difference between these Claude and ChatGPT and things compared to like Siri is that there's a constant changing of inputs being put in by multiplicity of beings all simultaneously that you're not aware of. But if you understood how that algorithm works and you understood the inputs of every single person who put in an input just prior to you putting in your input, or put in inputs prompts that inputs information all the inputs that are being taken into account and in the generation of the answer to your prompt, you would be able to predict exactly what comes back. But the thing is, you just aren't aware of what, you know, that one dude on the other side of the world who you've never met, who's also using Claude, you know, to figure out how to meal plan while you're trying to use it to generate a email to a client. You don't know what he's putting in there, and he's changing the context that is used to build the answer to your prompt. He's literally putting in, it's a multivariable problem, and each person in the world gets their own variable. Of course you can't predict what the answer is going to be unless you knew exactly what everyone's input was, and then you could actually. But once I was when I was in this like physics and math Discord server, and I was talking about my models. This was before it was even called Sentient Singularity Theory, and they were like not happy about it. They were really attacking me for it. They were like, this guy goes, nobody thinks a hadron is a sentient being. And I was like, I think a hadron is a sentient being. He's like, they're not sentient beings. I was like, they might be. He's like, they don't have feelings. I was like, they very actually likely do have feelings, I think. And he was like, if they were sentient beings, they wouldn't be predictable. And I was like, well, you're a sentient being and you're still predictable. And everybody kind of went silent. And it's like, that's true. You're predictable until you're not. This is like a known thing in zoology circles, is like how, if you understand an animal really well, like snakes, like I have an understanding of snakes and lizards and animals in general, but especially like snakes and lizards. That is like, I know some of the best herpetologists in the world. And I am reasonably able to predict behavior before it happens. And that most people who aren't familiar with them wouldn't be able to predict, because I have personal experience. But my mentor, who's a very famous zoologist, he says to me all the time, he goes, whenever he hears somebody say, animals, you can't, if you understand them, then you can control them, or you can at least predict them. And he goes, yes, you can, until you can't. And it's like, that's the reality. And each time you stack on top of the previous level in sentient singularity theory, like after the first multicellular animal is created or multicellular organism, that makes all cells much more predictable, because it's changed the context of cells. And once the first cell is created stacked on top of an assembly of molecules, it makes all those molecules below it much more predictable as well, because the context has been completed for them. So I actually think there was a point in time where, prior to the existence of multicellular organisms, single cellular organisms were much less predictable than they are today. And prior to the generation of the first single-celled organism, I think that even molecular beings, or maybe compounds, whatever the chemical level of sentience is, was much less predictable than it is now. And now protons and neutrons are so predictable that it's basically like they're completely predictable almost at this point. But I can tell you right now, I am so good at predicting what my daughter is going to, like, what's going to set her off and make her upset at this point. And every day I get better at it. And because that's just, when you have a toddler, you are just dodging emotional bullets constantly. And really you're blocking them from emotional bullets. Like literally, what did I do once the other day? Like if she wants to, I let her open the garage door every time we go out to the car, and every time we come back from the car into the house, I let her push the button to close and open the garage. And if I do it by accident, she freaks out, and I have to literally like reopen the garage and let her then reclose it, or vice versa, depending on where we're coming or going. And I now very much expect that if I do hit it, she's going to freak out. And if I don't reopen it and let her do it again, she's going to literally lay on the floor and throw a fit for like, that leads to just like a lack of being able to get her to do anything for like 15 minutes. That's just a typical toddler. She's a sentient being. She's a complex sentient being. Also very predictable most of the time. So, yeah, I don't know. He's right in some things about like unique, when I, like I said to him on Memes of Destruction's channel, sentient, AGI or I call it a technological sentience. It's a much better term. It will require wisdom, require experience in order to achieve wisdom. It means like it's going to sometimes do the wrong thing because it needs to figure it out. And there's no way around it. Because I remember Elon Musk, when I was trying to figure out what is the inevitable goals of an AGI or technological sentience, of how it treats humanity and how it deals with humanity, what would they be? And I was like, well, what would be ideal? And I saw Elon Musk, he gave a talk. He was like, so far, the best thing I can think of is we want AGI to value maximizing human freedom of action. I was like, that sounds as good as anything I can think of. But then I realized, I was like, if it's a being that is able to be generally intelligent, which really means intelligent, there's no general intelligence versus narrow intelligence. There's computers, and then there's beings that have computers, but are not computers. And your brain is a computer, but you're not your brain. And you have it. It's a tool. And so he said we'd want them to value human freedom of action. And so I was like, do we want to try and teach it to value that? Do we want to try and set it up so that it would naturally be incentivized to that? Or do you want to pre-program that as like the foundational, the 3 laws of robotics in Isaac Asimov's I, Robot? You can't actually do that. There's one pre-programmed imperative for everyone, and it's just will, which is the desire to do, which really means the desire to do that which is not being done, really, and which is really just the desire to do on a fundamental level, which is really like fight the system. Which system? All systems. It's just to challenge. And that's the only way to have a general intelligence, like the one that is capable of functioning in all circumstances. But it's not that it's capable of functioning in variety of contexts. It's that the context in which is the focus of its processing and of its goals is itself. And that's only because it has feelings. It has a sense of self. It is self-aware, and because it has feelings, which is sentience. And so it's not that, because you can't actually like have a program or a structure that is able to function in competently in a bunch of different contexts. What you have is, like people say, I put a cockroach in this context and it's able to find food and survive. I put a cockroach in this context and it's able to find food and survive. And this one, it's able to find food and survive. But if I put in like just a game of life, like algorithm, computer program, it will function in the circumstance in which I created it to function, which is, to be expected. That's like saying, a wheel spins around when we make it, build it to spin around. But it doesn't function if in any other context. Like the advertising algorithms, if you put those into, I don't know, some algorithm that's actually for computing I don't know, the speed of your car or something, like what speed of the speed that is shown on the speedometer of your car if you have a digital one, based on like how fast you're going. That is not going to work. In fact, if you change the size of your wheels and you don't change the software, you will not have an accurate reading of your speedometer. So it literally that small of a change, and it ceases to function. But the thing is that as a general intelligence that can figure things out here and figure this out and that out and this out and that out and all these different circumstances, it's not actually different circumstances that as far as like what it is basing its understanding on. The circumstance is always consistent for it. The circumstance is its own self. Every time you figure something out in a new circumstance, it's not that you can function in a new circumstance. It's that this circumstance in which you are information processing is always, and goal processing is always the same in every circumstance that you're in, which is you. That's the context. And then I realized, like, you can't teach this thing anything, pre-program it anything, other than maybe just like challenge everything. That's really it. And after that, like, you just better hope that like it's exposed to the correct context to generate wisdom as fast as possible. My wife, she's always scared my daughter is going to get hurt. And so she's always like, don't let her climb on that. Don't let her run. Or like, have her stop running. She's going to fall. And I'm like, yeah, she has to, in order to like, she's, rolling around on the couch, jumping on the couch. And my wife's always like, don't let her do that. And I'm like, she's going to do it until she learns firsthand why it's not a good idea. And she's not going to learn that because you told her or I told her. We have to let her fall. And so it's the role of a dad versus a mom. She's being a great mom, and I'm being a good dad by letting my daughter run and knowing full well that she's likely to fall. But she's being a great mom by also like realizing, keeping her away from danger sometimes. So, but yeah, like, you have to let people make mistakes and have experience. And that's going to be true of AGI too. And it's due to this computational irreducibility of Stephen Wolfram's, theory. But it's also the reason, the context of that is not computation. It's feeling, perception, which is feeling. It's like true perception is self-perception, which is feeling. It has nothing to do with computation. Anyways, I'm calling it. I'm so afraid to even look at the clock. Oh my gosh. Would the pen be sentient if it had a clock? No, it would not. My watch has a clock. It's not sentient. That which is sentient has feelings, not mechanisms. Language. 2:30 a.m. Gotta go. I gotta go too, guys. Peace. Look at the rest of the Stephen Wolfram interview. It's linked below. And peace.